Present. Board Member Yeager, Vice Chair Ricardo, and Chair Buoyancy.
Present.
Great,
thank you.
Before we get started, I'm going to ask my colleagues here. This is being broadcasted and recorded. Make sure that your mics are all properly positioned. And audience, if you can't hear us, if you could just, wave a finger or something, I'll try and correct the situation for those that are in the room. And so do we have somebody who can't hear already? Are we fine? Okay. So first, let me start by welcoming BART Deputy General Manager Bob Powers and his staff sitting over here. They will be joining us in doing part of the presentation. And so I really do appreciate their presence here and the work that you guys have been doing to help us deliver this up to this point in time, and look forward to hearing what you have to say. I also want to say thank you and appreciate my fellow board members for taking their time to attend this, which is the second of our workshops. And a reminder that these workshops are all part of trying to bring us up to speed and giving us a chance to dive down as deep as we want to on some of the issues, and leading us to the decisions that will be made later. So I remind you that this is our opportunity again to discuss major decisions that will impact this service extension both during construction and for the next 50 to 100 years, hopefully more like 100 years. So we will be listening to staff reports, and which includes again BART report as well, and I welcome all of your questions in terms of helping us get to that decision. It's important to emphasize that we are not taking the official action today. After hearing staff's report, we will have time to consider the information we've received and be prepared to make our decision, which is currently scheduled for our meeting in October. I think we are all mindful of these decisions will have a long-lasting impact on our residents in the region as a whole. So at this point, I'd like to ask Nuria to make a few words.
Thank you very much, Madam Chair, and good morning. As you stated, this is the second of the two workshops that we strategically separated so that we could spend time back in August reviewing the history of this environmental process and of the project, and then also identifying the various options for station entrance location and placement, in addition to the tunneling methodologies for the construction. Today is yet another opportunity to go into more detail. We have been joined, as you noted, by the members of the executive team at BART and their technical team. And this is very important because it's not only are we building this system, but they're going to be operating and maintaining it. And we want to make sure that we continue to work collaboratively. It's been really a wonderful partnership that we've had for several years since the beginning of this journey. And it is a commitment that we're making to Santa Clara County and to this region when that partnership then does the handoff, because this is, as I like to say, it's a marathon, but it has relay phases into it. When we do this handoff into the operations and maintenance, and this operating relationship is going to be one that's going to be with us for many, many decades to come. So I thank BART for being here. I thank them for their partnership, and I look forward to the presentation and the questions from the board. Thank you.
Okay, then a few housekeeping items before we begin. So our meeting, like I said, is being live streamed, and we also have B104 as an overflow room. So if we have people who are coming in and there's not enough seats, you can go to the overflow room. I encourage my colleagues, we're going to play by the same rules we did at the last workshop. Basically, the presentations, we will let the speakers make their way through their presentations. Then we have the question slide. That's our opportunity to ask questions, and then we can move on to the next segment. So again, hold them until each of those segment breaks, if you don't mind. And then in terms of the public, what I'm going to do is we'll take public comments, which is item number 2, for items not on the agenda. But then for public comments for those items on the agenda, i.e. 3.1, or item 3, I should say, we're going to take those public comments at the very end. I'm doing this because that way I feel that the public will have the benefit of hearing all of the presentations, all of the discussions, etc. So when you come up to speak to us, you can do it in the context of what you've heard today. And I would appreciate your patience in doing it that way. And again, if you would like to speak, please fill out a blue card and do so and bring them up, because it'll also allow me to plan for how much time to hold for public comments at the end. Okay, so with that, our agenda is full, and so we're going to go ahead and get started. And so I'm going to start with the first item, which is public comments for the items not on the agenda. I have one speaker, William McDonald, and if you have 2 minutes.
Good morning, Madam Chairperson, Bruins, and General Manager Fernandez, all of the board members, any of those from, also from VTA. I was not able to list all of the concerns, but for 2 minutes, there is a concern. Riding the SCVTA Route 23, and the bus number is on there on the card, and have noted in other areas as well, coming 64, the number 64 as well, outbound at Bird and San Carlos, and at other locations, motorists that swerve right out in front of the bus. Now, they have cameras. I've talked with the drivers already. That's all been recorded, but it's an ongoing problem, and the buses cannot stop on a dime, and that's something that needs to be addressed with traffic control. And also, that I didn't list on the card, I have been solicited upon and threatened on prior occasions of recent by parties who are not VTA passengers, and one particular out at, I think it's Cherry, out in that area, out Almaden Road, and then the other location would have been at Foxworthy, and that this is all outgoing, outbound, and that would have been Almaden Road as well. And then there are those soliciting downtown, outgoing, the number 64 at Bird San Carlos, right by the 76 station. And there is a poverty issue here in the area, but I think they see me with my pack, and they seem to think that I am easy pickings. And there have been problems in the downtown area with the light rail, Pasadena, San Antonio.
Thank you.
And
you know,
so,
I'm trying to stick to a strict timeline, but Tony Hung is here. If you would like to talk with him, he's standing right back there in the blue shirt, and you can go through the rest of your concerns and such with Tony. Okay.
I appreciate your valuable time.
Thank you. Okay, now we're going to move on to the workshop items. And so item 3.1 is to receive the draft recommendation of the BART Silicon Valley Phase 2 options. And Carolyn Gonot, our Director of Engineering and Transportation Programs, will introduce this item.
Good morning, Madam Chair and board members. Can you hear me? Okay. So I just want to quickly go through a quick overview of what the agenda would be for today. First, we would just do a very quick project overview. I know you've seen this a lot, but I'll do it very briefly. The criteria for the option evaluation that was discussed at the last board workshop in August. Then we're going to go through the station location options with the proposed staff recommendations for the 2 station location options scenarios, and then we'll have the presentation on the tunneling methodology options, where there'll be an overview of the technical studies that have been done, and then a summary of the recommendations. So just real quickly through the decision-making process, sort of what drives a lot of this is wanting to get to a record of decision on the project with the Federal Transit Administration by March, early March, and on which would require us to have a final project description in October, so we can release our environmental document in December or by the end of the year. So on August 25th, we did a history of what the Phase 2 project was and went through the environmental evaluation criteria. One of the key things also at that workshop was just giving you an understanding of the 2 tunnel methodology options that we were looking at. Today's board workshop really focuses on the recommended project description for the final supplemental EIS, environmental impact statement, and the supplemental EIR. And then at October 5th, we plan on bringing the staff recommendation for board action on the final project description. Just real quickly on the project overview, Phase 1 extension is under construction. We talk about it each month at the board meeting and give an update with the 2 stations, Milpitas and Berryessa, and we do plan on opening that by next June 2018. The Phase 2 extension, which is the primary focus today, is a 6-mile extension, which includes a 5-mile tunnel, includes 4 stations, 3 of which are in a subway configuration with Alum Rock, 28th Street, downtown San Jose, and Diridon, and Santa Clara would be, the platform would be at grade with a mezzanine just below grade. The Newhall yard maintenance facility is also at the end of the year, and the estimated cost right now is $4.7 billion. So this is pre-risk assessed, so we'd be adding additional costs potentially after we go through the FTA process. The VTA Bart Partnership, this is one where VTA primarily pays all the costs that are associated with the extension. We are responsible for contracting for any professional services and the construction for delivering the project. We're to construct to applicable BART and industry standards, codes, and regulations, and retain ownership of the infrastructure. The BART, they provide the technical assistance during this process, and they will be operating and maintaining the system. They set the fare policy, and they jointly coordinate with us on the service planning. Phase 2 project timeline right now is that we're currently in the environmental clearance phase. We plan on having the FTA record decision, as I mentioned, in March 2018. That allows us to proceed into the new starts engineering phase so that we may proceed in the pipeline to get federal funding. But primarily at this time, we're doing a lot of engineering, some of the pre-construction activities. We're able to start acquiring right away, and we're able to do some long lead time items like utility relocation and those types of activities. And then we hope to get the FFGA in December 2019 and have passenger service operable by 2026. Right now, the schedule to get to that New Starts project development phase, which is key for us to continue moving that project forward, is for us to select the final project description, which we have scheduled for the board meeting on October 5th, which I said. And so it has a number of steps of what would be happening. We would actually then release the final environmental document at the end, towards the end, I guess it would be actually in November, certify the final SEIR and approve the project at the January board meeting. BART board action would need to be required on the project description, and then a record decision is anticipated by FTA in March 2018. Just real quickly, what we'll be going over today is decisions on the project options, and there's 3 sets of project options. One is the downtown station, San Jose Station. We have a west option and an east option. We have a north option and a south option at Diridon Station. And we have the 2 types of tunnel methodologies, a single bore and a twin bore. In the federal alternatives analysis in NEPA, we have 2 alternatives, the no build and the BART extension alternative with the 4 stations. For the state document, the CEQA document, we have a no build alternative, the BART extension alternative with the 4 stations, similar to the federal process, but within the CEQA document, we also include it with the transit-oriented joint development alternative, which allowed us to use the land that we would use and integrate it with transit facilities and also provide joint development, and we are able to do that under our state legislation. I think I've mentioned this a number of times on the federal environmental process. I'm not going to repeat that, but the goal is March 2018 to get the record decision. And next, I want to talk a little bit about the criteria for the option evaluation. This was brought to the board last month. As I just mentioned, those are the 3 sets of options under consideration, one in the downtown San Jose, one at Diridon Station, and one in the tunneling methodology. The evaluation criteria we used, and it was shown when we for the attachments that were to the memo for this workshop, is we categorized it by the different evaluation criteria, but we used it to provide primarily qualitative and some quantitative assessment of the options. And we use it for our staff recommendation to the board of directors. We typically use this process on all our environmental documents on making a decision on options. We did request board input on the evaluation criteria at the last board workshop, and we did incorporate that, and we're presenting that preliminary recommendation today. So for the station location options, we have 5 categories: constructability, connectivity, economic development, project ridership, and cost. And I'll go through these a little bit more as we talk about the discussions for each of the station options. And for tunneling methodology, they're very similar, but it also includes passenger experience and systems operations. I'm going to move quickly onto the station location options. So for the downtown San Jose station, so there you see the station and the crossover box that would be built in downtown San Jose for the twin bore. And I'm going to go through 2. It's different for the single bore, so you'll see the differences. So this is for the west option, which is located between Market Street and near 3rd Street. The station would be built below 1st Street and 2nd Street, and there'd be a cut and cover box primarily going from Market Street to just past 3rd Street. On the east for the twin bore, the station box is the same size, but it would extend from just west of 3rd Street over to just the east of 6th Street. The primary entrance would be on the corner, the southeast corner of, is that right? Of 6th Street and Santa Clara Street. And that would also be the construction staging area. That just gives you a sense of what they similar compared to each other. For the west single bore, the station platform is below. There's not a cut and cover. It's in Santa Clara Street. The major station entrance would be what we call on the VTA block, or in that area, and near the Chase Bank, existing Chase Bank. And that would be the location of the station. The rest of the VTA block would be used as a construction staging area, and other areas that we show unread is also the construction staging areas. The similar for the east bore is that it would range from 4th Street to just past east of 6th Street, and that station platform would be below, so the cut and cover sections would be off street. We'd have a cut and cover section in the Plaza of City Hall for one entrance, and then the main entrance at 6th Street. So you'll see this crosshatched sections, that's the cut and cover sections. So if we go back, you can see where it is for the west, and then as well for the twin bore, which is a lot more cut and cover because we're cut and covering in the street. So in summary, on each of the evaluation criteria, we see that the constructability on that criteria, not going to go over all of this information, but the entrance is on the VTA property. That's really key. We actually own that property currently, and it actually provides a great opportunity for joint development in the future to be coordinated with the entrance for this station. On the downtown east option, we do have reduced impacts to transit because we're not impacting the light rail, because we don't build a cut and cover box and have to support the light rail or shut down one of the light rail lines at a time. So that has less. So it does have less impacts there. We are less out of the historic district that there is in the downtown. So there's reduced effort during construction as well, and that's also true for the single bore. On the connectivity, there's excellent connectivity. We're right at the Transit Mall for the downtown west option, direct access to the downtown employment center, and good access from City Hall and San Jose State. We are looking at trying to build an entrance that's near 3rd Street, which would be just a block off from that corner of City Hall and near San Jose State University. The downtown east option is direct access to City Hall and San Jose State, but a little bit further from the downtown employment center, where much of the new development and the higher densities will be happening in the downtown employment center area. And actually that's mentioned in the economic development criteria. We do believe that it does maximize developable area for the twin bore or the single bore for the station on the west, and reinforces a sense of place in that downtown area, which is one of the things that was commented at the last board meeting. The twin bore construction for economic development is it does extend into the downtown. It can extend the downtown core. It can activate the City Hall Plaza. There is some conflict with the towers, the SJSC towers. Those are on 5th Street, just north of Santa Clara. There is some conflict there in their development with their ability to build a station there. So for economic development, I think tends to favor the downtown west option. Similar ridership is anticipated for both. I mean, it is a downtown walking environment, and both stations have a lot of access to them, as long as we have that key entrance at 3rd Street. The base costs, primarily what's noted in the downtown west option is because we own the VTA block, there's much lower acquisition costs. On the downtown east option, we expect lower infrastructure costs, meaning less costs to support the light rail extension as we construct, and a lower utility relocation costs. So in summary, we see benefits on the connectivity, the economic development, and the costs for the downtown west option over the east option. So the staff's preferred alternative is the downtown west option.
Great. That brings us to any board questions. Go back one slide, please. Any questions? Give you a chance to cycle back afterwards. Okay.
I can also go through the next station options and then come back.
If there are no further questions, I want us to move speedily through the Diridon station. So if we could do that, we can come back, Glenn, if we need to. Go ahead, Carolyn.
Okay, the station location options for Diridon Station. We have a north station option and a south station option. This is the Diridon Station north for the twin bore. You see a cut and cover box just parallel to Santa Clara Street, just south of Santa Clara Street. One of the things that you will notice is that station does include going under the Caltrain tracks as well, in a cut and cover configuration south, and then we would be pushing a tunnel box underneath the Caltrain and allow Caltrain to continue operations. This is the south concept for the Diridon Station. It primarily cuts across a number of developable parcels. It primarily cuts across the parking lots that we have at Caltrain currently, where there's quite a bit of parking in there and expected for development in the future. That just shows the two different station options with the twin bore. With the single bore, the Diridon Station north, the actual tunnel would be under Santa Clara Street, and the station would be built just south of Santa Clara Street. There is some cut and cover at a lower depth right there to provide a larger mezzanine for this area to accommodate passengers and transfers and those types of activities. This is the Diridon Station south option with the single bore, very similar to the east option with a cut and cover section just near the, right near the, just south of the station area. And that's just a comparison of the two options. So on constructability, for the Diridon South option, the twin bore construction does reduce the impacts to West Santa Clara Street if we're on the south, but in the north option, we do avoid potential impacts with a lot of the developable area that's in the for the project that's what you might call the Trammell Crow project at Delmas, which is very difficult as we've been working with that developer at that time. For the south option with the single bore, the north option provides flexibility with regard to how the construction coordination goes with the other projects, and it avoids the potential impacts with the project Dalmas. Connectivity is very similar to both. It's to provide, when it is designed, working with the rest of our partners, we'll be developing something that is for an intermodal station alternative to connect with high-speed rail, future high-speed rail, our light rail system, buses, as well as Caltrain and the other rail modes that come in. Economic development, the Diridon South Station and the north option, they both have long-term benefits, but the footprint for the north station really does not provide a barrier to some of the development that would be happening. If we placed the box, the station box, in the middle of the developable parcels that are in Diridon South option. And that includes both the developable parcels where the station would be located, as well as the larger parcel where there's parking currently and there's a planned development now by Trammell Crow. Similar ridership is anticipated for both. And the infrastructure impacts, for South option, we have no conflict with Caltrain. There is impacts with the Caltrain Guideway with the north option, roughly $50 million. Potentially, we haven't designed that enough. That was not in the original design. And there's a potential for more utility relocations because we're near the street, but that will be worked out. So with the Diridon North options, we see the constructability is better for the Diridon North options, primarily avoiding potential impacts with future development. On the economic development, that reason stands the same, that we allow more developable land, which will increase our ridership and actually make that a much more vibrant sense of place in that area. And the cost is slightly more for the Diridon North option, but the staff recommendation is for Diridon North. So our two staff recommendations, proposed staff recommendations at this time, is for downtown San Jose Station, the west option, and for the Diridon Station, the north option. And questions then?
Okay, great. Question time. Board members, do we have any questions on the station, either the Diridon Station or the downtown San Jose stations? We're all good? Okay, great. Thank you very much. That will move us over to tunneling methodology. And so here we're going to have Dennis Ratcliffe. Dennis, I think you're going to lead us off here. I think we're going to have followed by the consultants, and then Bart will also come into this one after. So I think it's going to be Dennis, consultant, Dennis, Bart. Is that correct? Okay.
Thank you very much. This is the section where we are deciding between two tunneling methodology options. It's a very important decision because it drives a whole lot of the way the system will work. We have two options, as Carolyn indicated: twin bore, which is a traditional subway configuration, and we have single bore, which is a relatively new concept. We're going to go over the details of those. I know that we have presented to the board those configurations before, but I think it's useful to just have a quick overview so we know what we're talking about. And the subsequent discussion will be talking about some of the engineering aspects which address most of the frequently asked questions or issues that seem to draw more discussion. So why are twin bore and single bore? Why are we studying the single bore? Single bore for transit it's not a new concept. It's been studied before. It's just not been implemented in North America. Generally speaking, when we initially started the SBRT program, we were pursuing a 16-mile project as to be delivered as one project. And through a variety of circumstances, we needed to phase the project. And at that time, we decided to defer implementation of the next 6 miles, which is the tunnel section. So once we got successful implementation underway for BART Phase 1, with the encouragement of the Federal Transit Administration, we reinitiated examination of the BART Phase 2. And in the period past, 10 years had gone by, and things had changed. So to reinitiate the evaluation of how to deliver Phase 2, due diligence would require that we examine our assumptions. We did that by examining the alignment and the station locations and tunneling technology. And through exhaustive outreach to the community, we concluded that the alignment as originally conceived is generally what the community wanted and would serve our purposes for transit, and that the station locations, number and locations, were generally the same with some slight variations, which Carolyn just described. However, when it comes to tunneling technology, things have changed quite a bit, and in particular, the large bore diameter tunnels. So when we were initiating the initial work on BART Phase 2, the conventional approach is to have 2 single bore tunnels and cut and cover subway boxes for the stations. Single bore for transit would require a very large bore diameter compared to what was conventional at that time. But in the 10 years that passed, certain things have changed that make the larger bore more feasible. Generally speaking, there have been a lot more large bore diameter tunnels implemented worldwide, and that the controls for the tunnel boring face, which is critical for controlling surface effects, had gotten much more sophisticated and reliable. And then also large bores had been implemented more numerously, so industry had experience about how it works and what to expect. And all of that translates into a more reliable large bore implementation. Before I go into more details about that, I just want to suggest or indicate that the tunnel bore is really a structure. It's just a tubular structure that gets created, whatever size it is. And it's really just a construction that will contain the transit system in either case, twin bore or single bore. So the real examination needs to be more about the transit system that's contained in the tunnel and at the stations. So when we decided we were going to, let me go through what we're talking about here. So just generally speaking, between the stations, you see 2 different tunneling configurations. On the left is twin bore, on the right is single bore. The twin bore has 2 approximately 20-foot diameter tunnels, each containing 1 trackway. The single bore has 1 approximately 45-foot diameter tunnel, which contains 2 trackways separated into compartments, making 2 separate trackways within the single bore. Just to give you a sense of the size of the bores we're talking about, this is a 45-foot diameter tunnel boring machine, which has been used to construct a tunnel under the Istanbul Strait. This is generally the size photo of the inside of that tunnel. You can see the workmen in the middle of the photograph to give you a sense of scale. The alignment is something that needs to be understood. You have different configurations inside that tube. You have tracks side by side between stations generally, and you can see where that is located here. Also, you have crossover, which is an operational requirement so that you can do reverse running and go around any maintenance or obstructions on one track, so you can keep the system in operation in a reverse running mode. You cross over here. Also, at the stations, you have a different configuration where the tracks are one above the other and the cars are one above the other. You can see in this circle diagram here, you see the platforms inside the single bore, one platform above the other. And this is the key difference between the 2 twin bore and single bore configurations. So to get the tracks from side by side to one over the other, you have to have a transition. And you see the locations here where you have trains running one over the other, and the transition looks something like this, where on one end of the transition the tracks are side by side, and at the other end of the transition they have converted to a one track over the other. One of the key points of discussion about the differences between twin bore tunnels is cross passages between trackways. Cross passages are used in the event that a train is stopped mid-tunnel, that is between the stations, and passengers need to be removed from or have them exit the train that is stopped and be picked up by a train in the next compartment. In the single bore, this is accomplished by having a sliding door. You can see the configuration there, and those doors can be located generally as frequently as needed. When the trains are in a one over the other configuration, those doors lead to a vestibule and a stairway leading to the opposite track. This is just to be comparable. This is the general size of the 20-foot diameter bored tunnel. We would have 2 of these. And with regard to the cross passages, and this is a crucial element to understand, because the bores are bored separately, to accomplish a cross passage for operations and egress out of the tunnel, you have to create or build cross passages. The way these are constructed is after the bored tube is constructed, the builder will open the tunnel below grade, that is, take out the segmented panels for the tunnel and mine through to the other side of the next tunnel and open that tunnel and then construct a passage underground in that way. This is one of the key differences between the two options. To accomplish this mining, significant ground treatment typically has to be made, and the ground treatment is generally made from the surface by injecting grout and essentially creating a concrete block between the two tunnels. And it's the concrete block that maintains stability while the mining is going on. In the geology here, this can be done. It just is a little challenging in that some of the geology has granular lenses where it's difficult to contain the grout because the grout is under pressure and it kind of wanders off a bit, but it can be done. It's just a little challenging. The other aspect of it is at the interface between the tunnels. One of the key things about being underground here in San Jose is both of these tunnels will generally and frequently be under the water table. So they'll be under water pressure. And the interface between the cross passage and the tunnel is an opportunity for water intrusion. And this is basic engineering principle where you have different interfaces of dissimilar materials, ground movement and just heat or thermal expansion will cause them to move differently. And so creating a seal around these areas is always a challenge, although there's some techniques for applying a sealant on the outside. But it is something that needs to be considered. We also have penetrations of the tunnel not only for the twin bore but also for the single bore. This graphic shows the mid-tunnel ventilation configuration for the twin bore. As you can see, the two tunnels down on the right-hand side and a passage or a ducting structure that reaches the surface with the fan at the top. The single bore will also have, I don't have a diagram here, but it will look generally the same, except in this case, to reach both tunnels, we will have to do a cut and cover structure. It's basically a slot across the street to build that structure, and in the single bore it will be about half of the street, so there'll be construction impacts to the street, but it will not close the whole street necessarily. Again, just some of the differences. This is again cross-section at the station. I think I failed to mention that the depths are different at the two tunnels. On the twin bore, the depth is generally at about 55 feet where the platform is, and in the single bore, it's at 65 and 85 for the two different platforms. With regard to water pressure, they're slightly different. The deeper the tunnel, the higher the water pressure, and the more challenging it is to keep water out of leaks. Nevertheless, this is the station configuration, and this is another key difference. The station on the left for twin bore is conventional configuration. I think most of you have probably ridden BART and have experienced the underground stations at BART. And just generally speaking, you see up at the top where on the right-hand side of that image, there's a figure standing next to a BART logo. That's a head house. That's where you would enter the subway. You go down the stair and or escalator down to the platform level. and excuse me, the concourse level. The concourse is that white rectangle right above the stairs in the middle, and that is where ticketing occurs. And from there, you would proceed down to a platform below. That platform's in the middle, in between the two tunnels, and that's a center platform is called, and would allow passengers to go from one side to the other. And on the right-hand side is the configuration of the single bore tunnel. And what you see at the top is more of a building or a structure that has volume. And we would have ticketing at the ground level. And then you would proceed down stairs, escalators, or elevators down to the platform below. Whichever platform you choose would determine which way you go, or which way you're going would determine which platform you choose. So what you see there is the trains, again, one above the other, adjacent to the platform for one direction, and then below the train for the platform in the opposite direction. And again, this is going to be one of the key differences between the two tunnels. On the twin bore design, the access to the concourse area and the platform is not as deep, so the time required to get down there for passenger convenience, which is something that should be considered, is shorter. And then on the right-hand side, it's much deeper. It's what, I guess, about 20 feet deeper, 40 feet deeper, 30 feet deeper, excuse me, to the bottom platform. And that means you'd have to go down more stairs or more escalators or a longer elevator ride, perhaps. But the key thing here is, although the single bore is deeper than the twin bore, as transit systems go, and you'll see later in our presentation that it's not a deep station. It's generally within the range of many transit system stations around the nation. There's some other consideration we'll talk about later. But with regard to construction, on the left-hand side, as Carolyn indicated, it's a square box. We accomplish that by what's called cut-and-cover construction. And in the single bore, it's also cut-and-cover construction. The key difference here is that on the twin bore design, the cut-and-cover construction is in the street. And to accomplish that, you'll have to open the street all the way down to the bottom of the platform, or trainway at the bottom. And that excavation in our extension has two elements. One is the station itself, and the other is an adjacent track crossover, excuse me. And the combination of those make the length of that down the street almost 2,000 feet long, about 1,800 feet long, if I'm not mistaken. So how do you do that? So on the left-hand side is the cut-and-cover excavation. This, I think, is in Los Angeles, and what we do is we put in deep soil mix walls in the perimeter of where all of the excavation is going to occur. And then at one end, we would begin to excavate down. You see some struts across the opening there. That's to contain the soil on each side. And ultimately, you would hang or relocate utilities you uncover at that location. You put on a temporary roadway deck, and you proceed to the next zone, if you will, all the way down from one end of the station to the other. And on the right-hand side, you see the temporary road deck, and the excavation will continue underneath. And once the excavation is completed, the permanent structures would be installed below, constructed below. And once those are constructed below, then we would basically reverse this process to remove the temporary road decks and restore the roadway surface. The timing of, length of time this would require, that process of excavating and putting in the roadway deck, generally approximately 2 years. And then after the construction is completed, the reversing the process is approximately 2 years. So that's the nature of the disruption we're talking about. It's not just disruption to the traffic, it's also a significant amount of work to address the existing utilities. You never know what the condition is. You may be able to hang some. You'll probably have to relocate some. In San Jose, it's a relatively old city, and especially the gravity lines, that is the storm drains, are of unknown integrity. And relocating gravity lines actually extends out beyond the area sometimes so that you can make the gravity flow, let the system flow. For this construction, you see the general configuration. On the left is what I call the head house, number 4. That's essentially a cover for the stairs and the escalators, and it goes down to the concourse level where you would get ticketing and then go down to the platforms below. This is 19th Street BART Station. That's pretty prototypical of this configuration. You see the ticketing up on the left and the platform below. I put these photographs in here because you can see on the right-hand side of the photograph below the vertical circulation elements, that is the stairs and escalators, and the footprint of those take up some of the platform space. So you have some sort of negative spaces between the platform. On the other side of that stairway is another platform, so you have some sort of crossing areas between the stairs, but at the stairs, the platform's a little bit more narrow. And for the single bore, it's a completely different configuration. As you can see, it's still deeper. You have platforms on the one above the other on the bottom right there, and we have the potential for high-speed elevators, stairs, and/or escalators. The station access is at the surface, and the ticketing would occur at the surface. One of the key differences here between twin bore and single bore is for ADA access. In the single bore as conceived, you would access the concourse with one elevator, you would conduct the ticketing, and then you would take another elevator down to the platform below. Whereas in the single bore, you can get ticketing at the top and take one elevator trip down to whichever platform you're trying to access. Just as a conceptual rendering of what can be accomplished with the single bore, as you can see, this would be taken from above the grade level at grade where the ticketing would occur, and then you would access the bores below. You can see there are 2 different elevations on the bottom left, and you can take escalator, stair, and or elevator to either of those locations. At the platform level, this is again just a concept, and you would access the platform after reaching the platform level through this sort of triangular shape where this woman is exiting. That's called an adit, A-D-I-T, and for each of these stations you would have 2 of them, approximately at quarter points in the station, and those may be 20 feet wide access points. And the other issue that we'll be discussing a little bit more is point of safety. So another key aspect of transit design, just like in the tunnel, we have to provide for passengers to be able to be evacuated from the tunnel. We have to do the same for the stations. And there are criteria for these, and just generally speaking, in the design for twin bore, we would have to establish what's called a point of safety, or at least a safe place or zone that would be able to contain the passengers in a safe environment long enough for them to reach exit to the public space above. That is the grade surface below. So on the left-hand side, you see that point of safety is established at the concourse level. And on the right-hand side, you see the space is established in the vertical circulation structure and the adits. So there are criteria for this. The 2 main criteria. One is you have to be able to evacuate all the passengers from the platform in 4 minutes, and the passenger the most distant from the point of safety or place of safety has to be able to reach that place within 6 minutes. This is accomplished generally in subway by the ventilation system, and essentially the protocol for emergencies in a subway is for a train undergoing an incident would make its way to the station, and passengers would be evacuated at the station. Under such circumstances, the ventilation system for the subway would be activated, and air would be drawn away from the station down each direction of the tunnel typically, which would pull fresh air in from the surface from the openings to the surface. And that fresh air is what establishes a safe zone for passengers to reach the surface. And there are models that we have conducted that establish how that works in each of these configurations. Okay, so what I'd like to do now is to ask my technical experts to join me from HNTB. They're setting up. I'll just introduce them. Sanja Zlatanek from HNTB has approximately 3 decades of experience in mega projects, large bore tunnel design, engineering management, and construction management. She's an internationally recognized expert advising projects of this nature internationally. I also have Sean Cassidy, who is a expert in ventilation and fire egress, and he'll be speaking as well. Before I get on to their part of the presentation, I just wanted to say that when we decided that the single bore needed to be examined further, we first conducted a feasibility study. And to establish feasibility, there's really just 2 questions that need to be answered. Can it be constructed, and can it be operated and maintained safely? Once you've answered those yes in each case, all of the rest of the examination is to evaluate what's involved in achieving those outcomes. So to do that, we engaged HNTB to conduct a single bore technical study to address the key issues associated with the design, because ultimately we are going to need to compare the 2 options. Well, you might wonder, how are you going to compare a concept to a twin bore design, which is 10 years old and about approximately 50% complete of design? So we don't have to complete a 50% design of the single bore, but we do have to bring the key engineering issues up to a comparable level of understanding between twin bore and the single bore design. And this is these are the services that H&D had provided us. And generally speaking, the things they established for us were the bore diameter, the track alignment and operation, station configuration and operation, the ventilation concept, and the egress modeling. They also provided us with cost and schedule information, which will be compared later. Generally speaking, the conclusion is that either of these options will work for our extension. The comparison will come later. I just want to have a little bit of introduction to the engineering that we conducted in this regard. The studies that we've conducted have been ongoing for about 2 years, and they represent thousands of hours of examination and consideration of the issues involved, and hundreds of years of engineering expertise and experience have been applied to this examination, including considerable expertise and experience from experts in the BART organization. VTA and BART have been working closely together since the comprehensive agreement was executed about 16 years ago. And as Carolyn had indicated earlier, the general arrangement is that we will meet the requisite standards in our design and construction. BART will operate the system, and VTA will pay all costs associated with the design and construction. And that includes the cost of BART's commitment to our studies. That has been going on for 16 years. To date, just as an indicia of the magnitude of coordination VTA and BART have done in implementing Phase 1 and studying Phase 2, VTA has reimbursed BART for its commitment to our program in an amount totaling almost $65 million. So through these collaborative efforts, BART has given considerable input to the studies that we're going to go over. They have summed them up in 3 key pieces of statements of concern. The first in September of 2016, and that informed the scope of the work that HNTB had conducted on the single bore technical studies. And at the conclusion of the studies, again, restating the primary concerns in implementing a single bore, and then again just a couple of days ago. And all 3 of these correspondences has indicated a desire for additional study. And it's natural to always want more information when making a very important decision, and this indeed is a very important decision. But at some point, you have to acknowledge that you cannot know everything about what the future holds, and you do have enough information to make an informed decision. So we believe that we have created, or at least developed, requisite information to make that decision, and we hope to present that to you now. And I'd like to introduce Sonja. Thank you.
Interest in single board concept transpired primarily due to its ability to address growing community, businesses, and third-party concerns related to construction impacts to downtown San Jose. As demonstrated through VTA's previous single board feasibility study, single board construction option did not exhibit any aspect of fatal flaw. Single board tunnel technical studies provided detailed verification of the findings of the single board feasibility study, had the goal of addressing BART questions, especially in relation to tunnel optimal diameter, tunnel depth, track alignment, underground station configuration, passenger circulation, tunnel and station ventilation, and emergency egress aspects. This method has been successfully implemented internationally already for transit systems, since this is an innovative method in the United States for transit. We were very sensitive to BART requirements. The studies incorporated BART's input, especially in terms of safety, operations, and maintenance, and closely followed BART facility standards, other applicable codes and standards, including NFPA 130 standard for fixed guideway transit and passenger rail system. Single board study core team included selected experts from both companies, HNTB and WSP, with specific niche experience and ability to lead every specific task. They were supported by peer reviewers with at least equal or broader experience in the field to assure quality delivery in every area. Tunnel tasks were supported by independent national and international experts, because large diameter tunneling, although in significant rise internationally, is still breaking the ground in the United States. The team worked hard to provide an objective and unbiased assessment of this construction method to unlock its potential to minimize disruption to the community and businesses, while at the same time meet BART requirements in terms of operational, maintenance, and safety aspects. Large advances in TBM tunnel methodology made this study possible, as TBM diameters were becoming larger and machine controls and other systems have becoming more sophisticated, allowing improvements that led soft ground tunneling in very complex geology and hydrology to be carried out with less risk. These are some improvements in tunnel methodology for large diameter TBM machines that have been basically developed in the industry past 30 years. Our team had recently worked together on two significant projects involving large diameter tunnels. First one is Istanbul Strait Crossing, 3.3 kilometer, 45-foot diameter tunnel connecting Europe and Asia beneath Bosphorus Strait through extremely difficult geology, hydrology, under high hydrostatic pressure in the area prone to high seismic activity. The tunnel was completed in 2016 and is in operation. The second tunnel is 57-foot diameter tunnel beneath Seattle, which had a successful breakthrough in April this year and is scheduled to be completed in 2019. We had applied our joint experiences and lessons learned in the course of this study. In addition, team was inspired by the recent single board transit project, Line 9 in Barcelona, that represents the longest automated transit line in Europe. The line is 47.8 kilometers long, has 50 stations. Single board part of the line is built within 39.4-foot diameter tunnel that crosses beneath 4 active subway lines, and it's quite deep in places. Platform access is by elevators, escalators, and stairs. The station platforms are accompanied with platform edge doors. Both agencies, VTA and BART, were engaged in learning about this system through direct visits and contacts with the host agency. This slide is produced in 2008 and shows trends in large diameter tunnel use. Almost all projects shown on these slides have been constructed by now, with the exception of Orlovsky Tunnel at the top in St. Petersburg. And all these tunnels have been in service. In 2004, when this project started, as you can see, the size of 20-foot diameter tunnel in respect to other tunnels, the large bore tunnel technology had been under active use worldwide. Just yesterday, major tunnel online publications issued an updated list of large diameter tunnels over 14 meters or 45 foot in diameter that had been constructed or are under construction from 1994 till today. There are 38 tunnels on the list worldwide, and more are planned. With our national and international experts, we review developments in mechanized tunneling and critical lessons learned on some of these active and already completed projects. First task the team has done in the course of the study is establishing criteria. We assembled summary design criteria document with primary purpose of establishing and communicating critical design parameters and key assumptions governing the single board concept that first of all will meet industry standards of safe application of this state-of-the-art methodology in construction, and then that would accommodate critical, functional, operational, and maintenance requirements for both BART mainline guideways operating in 2 directions and for the station. Criteria document was coordinated with BART, and BART comments on the criteria and key assumptions were incorporated. The following key assumptions on the slide to single board study were developed with BART concurrence. We assumed that side-by-side configuration within the single board will be maximized, that we will use scissor crossover number 15, which allows higher speed through the crossover compared to number 10. We will use maximum train load of 2,500 passengers, which corresponds to 2,035 projections for passenger volume. We also assume that no point on platform shall be more than 300 feet from a point of safety, which is in direct concurrence with BART facility standards, that there will be minimum 2 elevators in paid zones, and that medium fire growth rate will be used for consistency with the original 2008 design. So using all these parameters, we determined the minimum internal diameter of the single board tunnel, primarily making sure that we are in compliance with BART facility standards, with their safety, operation, and maintenance procedures, and the tunnel diameter that we assumed and that worked for all changing configurations of the guideway through the tunnel was 41 foot internal diameter. We also allowed for future provisions for future design development in terms of structural fire durability, blast standoff distances, resilient tracks, floating slabs to mitigate noise and vibration in areas required. And we made sure that the seismic clearance envelope is also included per BART standards. To determine the tunnel depth, our first consideration was understanding geology and hydrology of the entire alignment through extensive geotechnical investigation program conducted previously for original tunnel option. The alignment lies on alluvial fan deposits, sand, gravel, silt, and clay. Bedrock is at much greater depth than the proposed tunnel horizon. There are 2 generalized soil layers, upper layer of predominantly cohesive soil consisting of clays and silts with interbeds of sand, much more pronounced over the western part of the alignment, and lower layer of non-cohesive soil with a top that varies from 50 to 80 feet below ground surface. The water table is expected within 15 feet from ground surface. You can see deeper single-bore tunnel horizon on the right and twin-bore tunnel horizon on the left, both in a distorter scale. It is anticipated that single-bore tunnel would encounter more of the non-cohesive soils because of its depth, and this condition would likely impact the selection of TBM type. Detailed parametric analysis of surface settlement due to tunneling were conducted at critical sections and locations. We are very confident that a minimum depth of cover of 50 feet at stations at an average 70 feet between the station is feasible, given geology and current performance demonstrated by pressurized phase TBM machines on other projects. With a minimum 50-foot cover at stations over the single-bore tunnel and volume loss value of 0.3% deemed reasonable and practical based on the current state of TBM technology and control systems, industry experiences and lessons learned, settlement and other criteria established for the project are met, and practical depth for station platform housed within the single bore accomplished. While establishing a station configuration, we consider primarily intermodal connections of the stations, right-of-way considerations, BART facility requirements that no point of platform should be more than 300 feet from point of safety. We knew that we have to include, to meet those standards, minimum 2 entrances, and that position of ventilation and system buildings will be very critical. They need to be positioned in proximities to both ends of the platform, and that practically space within the single bore for placement of ventilation equipment and ancillary room would need to be maximized for efficiency. So this is the practically station layout that we established at downtown San Jose station. Shows the upper platform level. You see the platform, which is in blue, 700 foot long per BART criteria. There are 2 entrances. First one between North Market Street on the left and the First Street is on VTA property. It also houses system and ventilation buildings and emergency corridor in right and emergency stairs. The left one is between First and Second North Street. Its eastern entrance is more utilitarian. You can see that both entrances are connected with both platform levels through adits. At the point of safety being at the intersection of adit and the platform is practically at the platform level, providing for high safety aspects of this option. The maximum is 222 feet from the practically walking distance from at the platform to the point of safety that exceeds BART BFS minimum standards. There are 2 emergency exits that connect both ends of the platforms. They lead into system buildings. The eastern building is between 2nd and 3rd Street and also houses the ventilation equipment, system rooms, emergency corridor, and emergency stair. The stations are housed within the single bore. So you can see, as Dennis explained, the stacked station configuration. Stacked platforms. Platforms are 15 foot 6 wide. They allow 29 square feet per person in operation in the level of service A. And this exceeds minimum BFS requirements of 7 square feet per person. The width of the platform also exceeds BFX requirements, which are 8 foot minimum or 10 foot minimum, depending if we are talking on non-continuous or continuous obstructions on the platform. This is the cross-section through the west entrance that could be accessed from 3 points, from Santa Clara Street, North Market Street, and VTA block. Passengers would enter the entrance at the street level, go through the fare gate down to the mezzanine level, which is 33 feet below the street level, and then we'll have a choice either to take shorter or longer escalators to reach the platform, upper or lower platform, which are 66 foot or 85 feet below the street level. This is the rendering that Dennis already had shown. You can see the ability for clear wayfinding. It's full of natural light and presents an opportunity for very significant civic space. This is a different view from the bottom of the lower platform. You can see natural light filling the station. And as Dennis had shown, this is the rendering of the platform, showing a 50-foot 6 wide platform unobstructed with the potential for clear wayfinding into the adits leading to entrances. At this point, I'll transfer to Sean, who will brief us about ventilation, fire life safety aspects of the station.
So the process of vetting and finding if this is a compatible system that offers a comparable operation and safety conditions, we went through a process of evaluating the ventilation systems that establish the safe conditions and also the operating conditions for the tunnel. The purpose was we'd need to make sure it was a viable ventilation concept that could be established with the single bore. Typically, it's the emergency ventilation system that determines the peak ventilation demand that these systems have. And then we wanted to make sure that with the developing fire hazard, we wanted to see if the single bore station could demonstrate that people could safely evacuate and that first responders could get access to help people that may not be able to because they're mobility impaired. The criteria that we used was the smoke visibility conditions that are developed within the station during a fire event. From a fire incident that would be generated in a train that's sitting at the platform. We're also monitoring how the temperature would start to increase because of the fire and also the buildup of carbon monoxide. So what we found is that the single bore ventilation operation was the same as the twin bore. There is an interesting feature of the single bore concept, and that is that the platforms are segregated from each other so that you don't have a common airspace between the two trackways. This continued to show us that it was a very similar operation that you could establish with the same equipment and the same configurations with trackside dampers and other features that are in the BART system now. We also saw that because of the segregated platforms, the system was a little bit more efficient at establishing airflows in an incident trainway. So you saw earlier that these trainways are actually segregated within the single bore liner. So it functions very similar to where we have cut and cover divided trainways throughout the system. Another thing that we saw was that the station geometry was more efficient at mitigating fire hazards in the egress passages. And this was because the opening that is connecting the platform to the vertical circulation concourse is a lateral opening. It's not an opening in the ceiling where people have to go up through a stair set to get up into the concourse. So this set up a condition where the smoke would not just automatically follow how the people are trying to get out of the station. And then the last thing we found was that the single point of safety could be established at a shorter distance from the incident platform. We were very concerned that point of safety conditions were maintained with the single bore concept according to all of the standards that are currently in force for this design of this system. So we went through the BART facility standards. Several different sections apply to this. There's an architecture section, a civil section which defines point of safety location, and then there's also a mechanical section that defines how the ventilation system is supposed to establish a clear evacuation path of fresh air. Then we also found where the references back into the CBC, the 2016 CBC, were maintained for how we could establish a point of safety with a protected enclosure that provides a safe place for people to get out. And we also saw where the CBC was referring back into NFPA 130, which allows the concourse area to be established as a point of safety. So we carefully looked through the codes to make sure that we could establish a point of safety that was appropriate. And this is an example of a diagram. I think you've seen a different version already, but just to explain, when there's a fire incident in one of these platform enclosures, the ventilation system starts an exhaust process, and that pulls out the smoke in that platform area, and the makeup air comes down through the vertical circulation concourse that has the atrium, and that fresh air keeps the smoke in the incident platform, establishing a point of safety right at a boundary that's between the platform and the adit as they enter the adit. So one of the other concerns that we had with could this single bore system be compatible with the alignment, and is it comparable in how it operates, was how does the pedestrian circulation function for this particular concept. So one of the ways that we did is we applied the same analysis that was done for the twin bore concept that had been done previously, and that's through a spreadsheet analysis where we're calculating how quickly people move in a lateral fashion across the platform, and then how quickly they go upstairs. But we went one step further and took in and established a computer simulation which goes through and treats each individual person and their abilities to move in a human pattern and a crowd situation, and that computer simulation is typically referred to as an agent-based simulation, where we made sure that we could establish queues that were safe for people to get out of the station. Key criteria that we're looking at is, can we clear the platform in 4 minutes? We did demonstrate that we could do that, and we also demonstrated that they could reach a point of safety in 6 minutes or less. The assumptions that we used was a peak train load of 2,500 people. That's a very, very heavily loaded train. And then also there's some other assumptions about an off-peak load in the opposite direction, so that's in that other segregated platform area, and then also a missed headway in the station. So there's quite a few people in the station during an event, and we made sure that they were able to get out in that time. So what we found with the platform clearance times, the lower platform was able to clear in 3.5 minutes, and this is the worst case is in an AM peak operating condition, and then the upper platform was able to clear in 3.8 minutes in their worst case, which is a PM peak operation. We did also note that the point of safety provided at the platform exits, so therefore people didn't just clear the platform in less than 4 minutes, but they also reached a point of safety in less than 4 minutes. This is an image of some of the computer simulations that we ran to confirm that the crowd flow and human movement behavior as people queued up to get out of the openings would be the station would support people getting out of the platform area in less than 4 minutes. And you can see in the top left is it starting the evacuation from the incident train and 30 seconds in, and then 1 minute you can see where the queues are developing, and then by 3 minutes and 30 seconds the queue has moved into the adit and people are in the point of safety area. So then the next question we had to ask ourselves to prove that the single bore concept was compatible with the alignment and comparable in the way that it functioned was how does the emergency egress function in the running tunnel? And what we found was that with the single bore configuration and the internal structures, we could provide cross passages at 300-foot spacing, which meets the design criteria that BART has set up for their system. And we've also note that that's less than what that spacing is less than what's required in NFPA 130 at 800 feet. We did take a look at this different special conditions that are established along the alignment. We found that there are 25 cross passages that do include a stairwell, much like the inner bay tube does. That has stairwells to get people into vestibules in between the track. But what we found is that there's 51 cross passages that didn't include a stairwell and were just a lateral movement between two tracks that are side by side. We did also check to make sure that the egress conditions between the tunnels would function at the track crossover conditions. We also did some another round of agent-based computer simulations for human movement using a tool called Fire Dynamics Simulator. And then we also checked to make sure that the rescue train concept wouldn't have any issues with the single bore. This is an image that you've seen already, but I wanted to just point out that this is a case where we're using a sliding door that it would be installed according to the current design criteria and design standards that is established by BART. And we want it's the same as what they have in their cut and cover station. So we were making sure that the single bore could be compatible with their criteria. This is where the case of the stacked tracks. And an interesting point that I'd like to make is that with this stair configuration and the gallery space that's allowed to the right of the tracks, we can establish a vestibule area where people who are mobility impaired can be staged until they're able to be assisted to go up or down the stairs. So this is another feature that we have with the single bore concept. Again, these sliding doors would be just the same sliding doors that are used throughout the system. And then we wanted to make sure that the transition section could support the cross-passage configuration for the rest of for the tunnel. And this is where we had done a study to show that as those tracks are being transitioned from side by side to a stacked configuration, we could provide cross passages that include stairs and longitudinal passages that work along the tunnel. And then we also confirmed that there is availability for a ventilation duct space that would allow us to establish another ventilation zone within the tunnel to assist with establishing safe conditions at the track crossover. I'll turn it back over to Sonia.
This is just an example it's a section through Deep and Deeper Station in the United States. We were curious, actually, in provided this study in comparison how deep we really are compared to other stations used across the country. So I'm not going to go through every single one. You can see that we are deeper. We are not very deep. But for the single bore study, in terms of point of safety depth, it's interesting that single bore provided point of safety at the platform level. So passengers do not have to overcome any elevation differences to come to point of safety. And that's not the case in many of these transit systems, transit stations across the country. Some of them, as Barcelona, there is also station, Fondo Station, Barcelona Metro at the bottom stated. That station also has a point of safety at the same level of the platform, as well as the 34th Street station for number 7 line extension, and Hope Station, currently built for regional connector in LA. The other station have point of safety at the concourse level, below the street level, and passengers do need to go through a series of stairs or escalators, which would be stopped in emergency to overcome this elevation difference to get to point of safety. So this is just for illustration how deep we are in comparison to other stations across the country.
Thank you. I think that takes us now to opening it up to questions from the board. Just one moment. And just a reminder, we're still not through the tunneling presentations, so we still have Aldea doing the risk assessment, and as well as Dennis wrapping up the comparative analysis, and then we still have Bart talking to us afterwards. So let's take questions now. Mr. Rennie.
Thank you, Chair Bruins. So I've been sitting here working through in my mind, the twin bore station has a disadvantage of the road being open and closed for 2 years. It was either 2 years or 2 years and 2 years, maybe 4 years. So I've been sitting here thinking, why can't you engineer a way to not do it that way? And I've, working through it, I see the stacked configuration has the advantage you can put the station on the side. So I'm guessing we can't put the station on the side in a twin bore configuration, because how do you get to the other side of it? You'd make people maybe go up to the street and walk over, and that wouldn't be reasonable. So then I started thinking, well, why not take the twin bore deeper so the station above it's not so close to the surface, and you could do a bore across. And I'm guessing that, when you bore a tunnel, you're able to bore and pour concrete right away, but you're not able to do that when you build a station. So I've almost got myself convinced that you have to do a cut and fill, I think you called it. But maybe you could comment on that more. Really, the question is, are there other engineering options to not have to do this cut and?
Well, there's a lot in what you're asking. So with regard to the mine station and not having to do a cut and cover, we've studied that a number of times, 2 times in particular. The geology is not compatible with the way you would do that, which is essentially, again, grouting in a concrete block to mine it out. There are various techniques for doing that, but because the soil has so many granular lenses and other geological features, it's really not an appropriate approach for our specific location.
And if you went deeper?
Well, I think we had a slide there that showed the different geology, and I think to the extent that you would go deeper rather than getting so deep it's really not appropriate, you're going to encounter those kinds of geology. With regard to building the station on the side, I suppose you could. That's not in our baseline configuration. It's not in our baseline cost. The nature of the center platform is that the vertical circulation elements become the critical element of getting people to where you need them to go. In that configuration, I'm not certain how that would translate into getting them to a point of safety. I suppose it can be accomplished. The piece of it that's a little challenging is if you're trying to put the station down below, there is a way to do that, is to put a larger, you'd have to locate the stations in a place where you could make a much larger cut and cover on the sides and put outboard platforms. We have not studied that. Doesn't seem like it's practical in our circumstance either. So, I think what I didn't say, and I was going to say later, is you're identifying that there's one other critical or key difference between the two, is the twin bore tunnel configuration can have access from the sidewalk on both sides of the street, whereas the single bore would have access from the sidewalk on only one side of the street. I don't know if I've answered all your questions.
I think that covered it. You have thought about it, and it sounds much more difficult, not worth pursuing further.
Like I said, we've studied it a couple of times. Thank you.
Supervisor Yeager, and again, reminder, pull your microphone close, please.
Yes, thank you. I was just sort of wondering, as far as the operation of the system, does the construction play a big part in that, or is it going to be the same regardless of whether it's one or the other?
Sure, I understand. And
the operation of the system.
Okay.
Is there much of a difference in that operation between construction of it?
You mean the configuration of it?
Yeah.
Yeah, okay. So generally speaking, the operations in the tunnel is essentially the same. The stack configuration is a little unusual, and I'm going to cover, kind of what that means to operations later, but generally speaking, it's not what exists in other parts of the BART system, so the maintenance and operating personnel would have to understand where they are in the tunnel, and it's different. It's going up one above the other, for example. And also the slope into the station is all within BART facility standards. There are standards for how rapidly one can slope up or down, and we've accomplished that as well. I also wanted to address the operations inside the tunnel. The configuration inside that tunnel is side by side as much as possible. That is the input we got from BART, which is what they prefer, to emulate the side-by-side configuration in twin bore as much as possible. It's also possible to keep the main trainways one above the other and do a crossovers on the side through a series of turnouts. It illustrates the flexibility of the single bore option for operations. Operations at the station will be different. Insofar as we have ticketing above, and in the current design, the ticketing at the mezzanine or the concourse area in the twin bore tunnel is different. That has a paid zone, which I think we would need to re-examine because BART has recent experience that suggests they might want to move the ticketing to the surface, or at least above the concourse area, so there's no free zone. But the other operating difference is the single bore option would require 2 station agents. The current design for the twin bore option can be operated with a single station agent at each location, although because of the free zone issues, we would need to reconsider that, and we very well might wind up with 2 station agents at the twin bore configuration. But operationally, the station agent monitors and regulates the ticketing and gate activities, and remotely, I suppose, also from OCC, monitoring the safety at the platform levels and others through mechanical or CCTV means. And they're roughly similar, although, like I said, the vertical circulation is much deeper or larger in the single bore concept. I don't know if
that was helpful. I mean, obviously there's a lot of information there, and things are different, but it sounds like at the end of the day, there's no real difference, even though you have to deal with certain aspects, one over the other.
Well, I don't want to discount the effort the operator would have to assert here. In either case, the personnel involved would have to be trained specifically for this configuration. That's not similar to other places on the system. So any personnel that were to be deployed there would have to be specifically trained to know how it operates. It's not extraordinary, but it is different.
Oh, if I can interject for a moment, for those of us that joined us a little bit late, we will go into a lot of more of the operations when BART will be presenting as well, and we'll be able to answer the operational questions as well.
Great. Yeah, just a couple other questions. Customer experience has a big role on ridership. Does the deeper option discourage how people are from using the system?
We've done a little research on what we can find about whether someone would not use a station that's 20 or 30 feet deeper, and we don't see any distinction in ridership. Ridership models don't do that right now, but we didn't see anything on that type of discussion. It's a discussion about whether someone would want to go at all into a subway versus not, but I haven't seen anything otherwise.
Lastly, which tunnel method will likely do better in an earthquake?
Well, structurally, they will perform adequately, each option. There is one peculiarity between the two that's relevant to the question. At the Silver Creek Fault, I guess that would be south of Highway 101 or west of Highway 101, there's a change in the U.S. Geological Services characterization of that fault, and it essentially says that it will be slipping more than it was assumed to be slipping when we did our prior design. And the way we would accommodate that is to be able to realign tracks over time. As it begins to slip, it will generally tend to, in very slight ways, bend, if you will, the tubes where the trains are located. In the single bore, because there's so much room in there, it's going to be relatively simple to accomplish. In the twin bore design, I'm not certain how we would do that. We haven't addressed it specifically, but I suppose one potential method to do that would be to put a cut and cover zone in there to make a larger area where it would likely need to be realigning, but we have not studied that.
Johnny Camus.
Yeah, at the risk of sounding like a bad student, I wanted to go back to slide number 86, if at all possible. I was trying to understand it, but I think you were speaking well above my vocabulary. And the chart really is not understandable to me either. And I have to, I know I sound like an idiot, but I really...
No, it is possibly confusing. So you can see two figures.
Yes,
And,
I don't know what all these lines mean. And
right, left one is represent twin bore tunnel horizon in distorted scale. So you can see non-cohesive soils.
are the non-cohesive soils
which are
gray
in non-cohesive are in yellowish,
yellow? Okay.
and cohesive are in bluish, okay, on both, or greenish on both slides. And you can see on the left side twin bore tunnel horizon through different geological conditions. You see a thin red line on the top, which represent the water level. And all these boxes.
Sorry, the red line on the top is the water level?
Pretty much so below the surface represent the water level, which is 10 to 15 feet. This is typical geological slide, so it's a little hard to understand. All these boxes along the alignment represent cutter cover stations. On the right-hand side, you can see deeper single bore with a deeper tunnel horizon, pretty much going more through non-cohesive soils, especially toward western part of the alignment. You don't see any boxes across the alignment because there is no cut and cover stations. The stations are placed on the side within the private properties. I hope this clarified.
Well, my main fear, and I don't know if I'm going to be explaining this correctly. You're drilling a hole down a tube. Where's the water? Is it the water is the red line? So we're actually underneath the water. The water table. So on both dual core and single core bore, we're both under the water, right? So where does the where does the water stop? Where is there like more solid ground? Is is it at
our alignment is pretty much below the groundwater level table.
Okay.
So we are within the groundwater. We have to, during the tunneling, manage different manage that water. Since in general, single bore will experience probably the range of 1 bar larger hydrostatic pressure than twin bore, but it's well within the range. It's between 3.5 to 4 bars. Dennis we mentioned Istanbul Strait crossing, also single bore double-decker tunnel that below Bosphorus Strait that connects Asia and Europe. It was constructed under 11 bars of of hydrostatic pressure. So this is what we experience. This project is well within.
Just a couple of things. That's a very technical explanation to a pretty understandable question. First of all, the cohesive and non-cohesive stories. We're basically talking about clay versus granular material. Granular material is filled with water. It's all under the water table. The water table in this area fluctuates from essentially the ground surface to maybe 10 to 20 feet below, depending on seasonality. But all of these alignments are under the water table. In terms of the cohesive and non-cohesive, cohesive is better for tunneling, and it is a factor in how you go about doing it. On the, I think the other part of your question was about buoyancy. I think we received that question once before, but we didn't really answer it. Generally speaking, the tunnel alignments are balanced, if you will, in terms of their weight and the weight of the water they displace, so they don't float and they don't sink because the soil is sufficiently stiff to keep them from sinking. But that is the environment in which we construct. The water pressure, 1 bar is 1 atmosphere, is 14 psi. 2 bars is twice that. 10 bars is 10 times that. And that's
I actually understood that because I'm a scuba diver.
Okay.
But other than that, so this thing is going to be floating in muddy water, basically, is what I'm trying to understand, right? Okay. And either way, regardless whether it's single bore or two bores, it's going to be floating in
It will be
muddy
existing
water.
in generally the same conditions, yes.
Okay, that's kind of what I wanted to know. Thank you.
Board members, Vayanathan.
Thank you, Madam Chair. If you could go back just 2 slides, it's at 84. Could you please explain scissor crossover number 15 versus 10? You briefly alluded to that. If you could explain that a little bit more.
Bore, because of the larger space within the bore, can accommodate larger number crossover that allows larger speed of the train through that crossover. In particular, number 15 allows 35 miles per hour. The number 10 would allow 27 miles per hour. Number 10 has been used in previous design because it's just shorter. So it still meets operational requirements, but requires less of an open cut and cover box to construct compared to number 15. In terms of the single bore, there is no difference. You can apply number 10, number 15, even there is a potential for a number 20 crossover that would further increase the speed of the train.
If it's single bore, you could go up to 20. That's
Yes,
what you're saying.
that's correct.
Okay.
And that causes less of a maintenance issue because you're talking about the special tracks.
Okay.
So those are some advantages. Yeah.
Thank you so much, Sanya. One other question, page 105. If somebody can, there are a lot of other stations that you talk about, San Francisco, New York. Is there anyone who can tell us how deep is Washington, D.C.? That's something I'm familiar with as a tourist, which is why I'm asking how deep. And I could manage those stations without too much guidance, yeah.
We were just talking, actually, about Grand Forest Station, which is all elevator station, which is 180 foot deep.
180?
180.
Okay, thank you very much. Thank you.
Member O'Neill.
Thank you. So in trying to get kind of a visual of it when we talk about the cut and cover, and being of a certain age that I am, and being a native to the area, I remember San Francisco Market Street with the BART construction and the cut and cover. I mean, it just kind of seemed, I mean, that just seemed like it went on most of my childhood and young adult years. And I saw the disruption and the impact that it had on the whole life of that part of San Francisco. So if you were to use, if we were to say, okay, we still want to use that technology, has it changed? Like you described, like putting in place the road deck. Has the whole process improved somewhat so that even if we were to choose that, we would not be reliving Market Street, San Francisco?
Well,
or maybe no one was here except for me when that one.
No, there's a couple of differences. Generally, it's the same. There are some improvements in equipment and the like. One key difference there: San Francisco streets are essentially wider than what we're talking about here in San Jose, which is quite narrow. But we also have Mark Ramsey here from our technical studies team, and he can talk about what the technique actually is. If you want to say a few minutes there.
Yeah, thank you. The beginning of the cut and cover process is the utility relocation or strengthening the utilities in order to support them from the decking that's installed. And that could be a year and a half long process before the decking started. And then after the utilities are relocated, then you need to do the walls, the supportive excavation walls, and then you start the decking process. And that decking process is when you start closing the street, start digging up the street in order to install steel members that go across the street, transverse to the street, and then the concrete precast or steel decking on top of that. As far as technology is concerned, there's really not much difference between the cut and cover stations that were done then and the ones that I've built all across the country in North America. There's really no technology that's been changed with that, and it is about a 2-year process to put them in and about a 2-year process to take them back out.
Thank you. My other question has to do with the ventilation and just even seeing what we're seeing with some of the horrific storms that people are suffering. So when I look at these ventilation systems, are they reliant on there being power, you know, so what if we had a horrific storm or a bad earthquake and the power goes out? Will there be either, you know, there's some kind of backup generation, or will the ventilation be sufficient from the street so that people can escape the smoke, or just being crammed into a small area with no powered ventilation?
So these systems are designed with a dual power source to the ventilation plants. And so the expectation is that if there's a severe storm, we have some redundancy in the power source that goes to that fan. But in the event where it is a catastrophic situation where all the power sources are put out, that's a challenging situation for any station ventilation condition. Then you begin to wonder, how well do these stations naturally vent, and then if they do, where does that smoke go? And typically, for the way that the modern station designs are, and I've had some experience in dealing with some of the old stations in New York that have these natural ventilation passages that are separate from evacuation paths. They have a chance to have some natural ventilation occur that would get smoke out. But in modern station designs where we don't put in those natural ventilation adits, because we've found as we've developed these systems that those natural ventilation adits can be detrimental to normal operations, and that's why we have that situation set up that way. But so it would be a tough situation.
Member Hendricks.
Yeah, just quickly about customer experience and trying to look at what it is for daily operation in either Twin or Bore. People are going in through tickets, they get down, maybe you're going a little bit deeper or not. It seems to me the only real difference from a customer experience piece is you have to know whether or not to be at which platform level. Is that really the major difference in terms of what people would see at an operational level, and that potentially is just dealt with signage and other things?
Well, that's certainly one of them. The other one is the distance to be traveled down to the platform. It may take you a little longer to go down to a lower, deeper platform than an upper platform, one that's not quite so deep.
But I mean, you get that if you could be at one station where it's 50 feet and a different station is at 75 feet. I mean, but it's really in terms of what your average experience is and what you need to know. In Twin Bore, you always go to the same platform, and in the dual bore, you go to the same platform. In this single bore, you have to know which one to go to.
For regular riders, they get used to it, but for the casual rider, it's a thought process. Even in the BART Phase 1 extension, which we're concluding the construction, at the Milpitas station, we have outbound platforms. That is, there are two tracks between the two platforms, and the same situation occurs there, where once you've gotten your ticket, you've got to decide which platform you're going to go to.
Not that unusual. Thank you.
Member Perales.
Thank you very much. So this wasn't on the slide up there, but this goes into the packet that we have, and two issues for me. One, certainly it's pretty convincing in regards to the constructability and what's going to happen during that phase in construction and the different impacts between the two methodologies. But then, and I know we're going to go into operations next, but during construction, there's obviously a difference between the two and how you have to construct certain things. And I know one of the ones we discussed was the tunnel emergency egresses and how we would have some of these. And reading this, one of the things that stood out to me was that a statement that says, with emergency egress passageways built into the tunnel for single bore, there is no potential for groundwater intrusion associated with egress passageways. And in comparative for twin bore, it would need, was stated, 33 cross passageways. And then more importantly, it mentions that those are points of vulnerability for water intrusion. Can you discuss a little bit more on what does that mean? And I know that that's under the maintenance, so that's obviously after constructability, but this is something because of the two differences, we'd have to construct what it looks like 33 passageways, which then become points of vulnerability.
That's right. The 33 passageways, they have two each penetrations of the tunnel itself, one at each end, and one for each tunnel. The reason it's a constructability issue is we're going to be trying to grout or at least seal from the outside, so it's sort of like a blind hem if you're going to sew it together. And, like I said, it's just going to be a constant maintenance responsibility to go and assure that those seals are continue to perform. The tunnel liners themselves, they're a segmented liner, so they're done in rings, as the tunnel machine advances. Those liners are essentially manufactured, so the quality control is extremely high, and they have an engineered seal around all four sides of them, and they're bolted together, and those seals are quite reliable. Also, the machine, when it's building the tunnel, extrudes a grout shroud around the outside of the tunnel to fill the void from the machine, and that grout shroud also contributes to water tightness. So the technology for the bored tunnel and soft ground is quite reliable as compared to hand digging and putting in the seals and what have you. So that's the main concern.
And I guess
I'm sorry, and the cross passages being inside that tube without a penetration of the tube itself is why that statement's in there.
Yeah, and it goes into what Board Member Camus was saying, is that no matter which methodology, we're in this muddy water, if you will, and so having to cut in more holes, that's what's creating that vulnerability. And then in single bore, all of those are done within the one tunnel, so you're not cutting. How many points of vulnerability are we talking about with the single bore, though?
Well, that's an excellent question because it's not without them. The mid-tunnel ventilation shafts will have a similar circumstance, wherein the ventilation system itself has to penetrate the tunnel at both levels to ventilate that area. And the station's adits. Now, the interesting thing about the station adits is they're concentrated. They don't run the entire length of the platform, so you have sort of a localized area. And we can accomplish that excavation through ground freezing because the water is so saturated it works there, and that's generally the concept we're pursuing. They're quite reliable, and it's concentrated, so you can really focus your attention of engineering and construction at those locations. Once they're completed, you still have a interface of dissimilar materials, and that would be a point of vulnerability. And not only at the tunnel, but also at the vertical circulation elements. And I just wanted to characterize those vertical circulation structures. It's essentially the same as any high-rise building with a basement. So that's generally how you should look at it.
Okay, but so safe to say the number of intrusions and thus vulnerabilities in single bore is significantly less. And not only that, the ones that there are also smaller as far as because the crossover paths, these are big intrusions into the tunnels on twin bore. Okay.
And also at the cut and cover station, it's quite a complex series of construction phases, and each one of those phases creates another interface of dissimilar materials and has quite a number of vulnerability areas for water intrusion as compared to the single bore.
Okay, thank you.
Okay, Member Chavez.
Thank you. I'm looking at the report. At the report that came in our packet, and I'm looking at
Your microphone a little bit closer.
that better. All right. So one of the this is under the station egress, and so first of all, I just wanted to ask when we're looking at safety, are we primarily looking at fire as the main? When you're saying a point of safety, we're talking about a point of safety from fire. Is that accurate?
So the analysis that we developed did use fire as the incident that was creating the unsafe condition. And that's one of the incidents that we know of that can happen from time to time, and it has a certain return rate that we expect. Now, there are other incidents that could be unsafe that are created in the station, that may not include a fire, but fire is predominantly the one that we are most interested to make sure the system can get up and establish a safe environment.
So what I was concerned about is since fire I recognize is a very likely scenario, I'm also concerned about what the implications are for other kinds of situations, in particular earthquakes. And it brought the question that, Dennis, that you raised about how people get in and out of a facility safely. And what I'm a little nervous about is a lack of redundancy relative to getting out from more than one location, which is one of the reasons I wanted, Dennis, if you could talk a little bit more about the 2 ways out versus 1 way out, and particularly when it means being able to get across a street above grade.
Sorry. This is the plan view of the downtown station, and you can see the 2 white squares on the upper side of the purple area being the platform. Those are the primary entrances and exits during operations. But you can see also there's some red lines that go to some gray squares there, and those are also emergency exits. So in terms of redundancy, you have 4 in this configuration exits, and I believe that that's pretty typical. The difference between the single bore and the twin bore is at the concourse and the twin bore, you can have multiple stair escalator entrances. They're typically 4. Sometimes there's more. But the vertical circulation from the platform is limited to platform square feet, so you can't keep adding to get it more. But there are several in each center platform for the twin bore as well. So I don't want to say so much difference, but the concept of evacuating the platform is about getting to either the white space there or to the red line. And once you've stepped off the platform into either one of those zones, you're essentially in a safe place. So
that's partly what I'm having the trouble digesting, is having a point of safety be below grade. I mean, so far below grade, and then understanding that as a safe zone. And recognizing, I saw all the examples you gave, but as I was thinking about it, and even having experienced it, it feels like the difference between having people in a safe zone so below grade and then nervous and trying to get out, the implications of that relative to how people do get out in a safe and orderly fashion. And one of the things I appreciated seeing in Barcelona was that some of those exits were relatively wide, but the width of the being able to walk up and get out seems very critical to me, and also whether or not a point of safety implies that there's a way to end an unsafe set of activities behind a screen that doesn't, or a door that doesn't stay open for an extended period of time as people are out. So both, that concerns me both as it relates to fire. And by the way, this would be, I think that the depth issue I recognize is more of an issue relative to the single bore, but the ventilation and the ability to have backup would be an issue with either. I think with either one of them. But I'm really just trying to understand when we declare a point of safety, better understanding what the black and the white of that is, if below grade versus above grade, which I completely understand because you're out.
So in terms of just the evacuation, once the passenger gets to the street, they're essentially no longer involved in the incident. So the point of safety is really an engineered space to allow all the time necessary for the passenger to get there. So the question becomes, how long does it take to get to that space? And then, the time it takes to traverse the space and get to the street are different in the 2 scenarios, certainly. And it is a consideration. But in both cases, the configuration will meet the recognized requirements for evacuation. That is, both single bore and twin bore will meet all of those requirements.
So just one last thought on this. I think when I read this report, I didn't, and maybe this is just something that you could help us think a little bit more about, is that the definition of a point of safety based on what you've given us is where you're passageways and circulation areas in each underground station, proper functioning and maintainability of the tunnel ventilation system. And I think this goes back a little bit to one of my colleagues' questions about, you know, when ventilation doesn't work, and even as a in an incident of significant, you know, whether it's a fire or something else, a terrorist activity, any of those things. What I really want to understand is, what should my expectations be about what it means to be in a what are the risks of the way we're designing or defining point of safety for our purposes? Meaning, I recognize that we're within the rules, and you made a really good case for that. I'm thinking even a little bit pushing the boundary beyond that a bit.
Well, again, I think the key thing that I think you're looking for is when are you free of the incident? And at the street, you will be considered free or outside of the incident affected area. And in the two configurations, there is a difference. There would be a longer trip from the single bore because it's just longer, and the twin bore is shorter to the surface.
Thank you.
Okay, I want to take one more question. Mr. Rennie, did you have another question? And
I actually going to ask a different one. I think Mr. Perales covered most of my question, but I wanted to just follow up on the safety one a little bit.
Can we hold that question? Because what I'd like to do, if you don't mind, hold the question, because Bart is going to be presenting as well. And so what I'd like to do, before we continue this presentation, I need to do a process check. I had asked staff to try and estimate how much time and such, and of course we can't always factor in how many questions we're going to have from the board. I believe you guys are staying with us. And so I think we're going to still have some chance, but I would like to move forward with staff filling in a little bit more information here. But the process check I want to do is, as we are sitting right now, we are, quote, behind schedule. So basically we're at risk in terms of not being able to end at 12 o'clock. So what I'd like to do is, we're right now about 30 minutes behind, can I get a show of hands in terms of people's flexibility on the board to continue on if we need to continue past 12 o'clock? So if you can do it, could you just indicate by showing your hand? Okay, I'll tell you what. If you cannot, show your hand. Okay. I don't want to go any farther than we need to, so I'm going to ask staff if we can kind of keep the pace going. And again, we're going to have a couple more presentations, including BART, and I think BART is the one that really needs to help us understand some of the operational safety issues, et cetera. Okay, let's continue on. Mr. Radcliffe.
So if there are no more questions, I just wanted to wrap up the technical studies portion of this and indicate that in this process, we've reached out to first responders. Certainly the BART organization has been involved, and we spoke and consulted with the construction industry, engineering professionals, obviously, and community stakeholders. And, the recommendations we'll be making are based on all of that input. The last thing I want to introduce now is what we do with all of this technical information is to kind of methodically compare the two in terms of cost and schedule primarily. And we've engaged Aldea Services to do that. And we have Mr. Bob Goodfellow is going to speak and talk to us about his work in that regard.
Thank you very much for the opportunity and for the time. And we, as the risk consultants, we'll try and mitigate the risk of going long best we can. A little closer, okay. Never very good at karaoke. Okay. So what we will talk about is we'll introduce ourselves and our team, look at our scope of work and our process. I'll flip it over to Jim, who will talk a little more about the quantitative work that we've undertaken, and we'll talk about what our findings were. So we had 4 key members of our team. Myself, I'm the Senior Vice President of Aldea Services, been in the States 20 years now, and but worked all over the world on major metro systems, including London, Copenhagen, and Hong Kong. Jim is one of our risk managers, and all 4 of us are risk managers of some experience, but also have primarily worked during our career on tunnels and underground structures, design and construction engineering. Jim has worked as a contractor and an owner, as well as a design engineer for over 30 years, including work on MARTA and WMATA. Alfred Murgeli is a sub-consultant to us, who is a health and safety engineer based in Switzerland and worked for over 10 years on the Gotthard Base Tunnel. And Angel Delamo is a tunnel engineer from Aldea Services, who joined us early this year, previously having worked on the Barcelona Line 9 project, some major infrastructure transit system in Istanbul, as well as Crossrail in London. The purpose of our work was to compare the two, primarily the underground components, and compare the two geometric options on the table here, twin bore and single bore. We looked, and we'll talk about some numbers perhaps a little later on, but these numbers are not meant to be budgetary in nature. I'll talk a little bit more detail about what that really means, but essentially we were trying to facilitate a decision-making process. Our own process was to get what we believed to be a sufficient level of input so that we could produce a risk assessment of comparative risk between the two geometries. So we identified risks and uncertainties. We put those risks and uncertainties into a qualitative model, translated that to a quantitative model, and then carried out a probabilistic analysis of that work. Moving quite quickly here, but we'll hopefully be able to answer any questions you guys have at the end. The scope of our task was to look at the two options as they currently exist, and that's a really important point, that we looked at the twin bore option at its current estimated 65% level of design completeness versus the single bore at its estimated 20% level of design completeness. We interviewed a substantial number of subject matter experts, generated some risk registers that we could work on from the basis of those risk registers in our risk assessment workshops that contained a number of people. I'll talk about those shortly. And like I say, made it a qualitative assessment, translated to a quantitative, and the bullets are slightly out of order. We are currently presenting our final results to you, that is correct, and but what still remains is to receive final sets of comments from the sponsoring agencies, VTA and BART, and to finalize our report. So I spoke a little bit about how the numbers we might come up with are not necessarily budgetary in nature, and that's because we discounted several factors that are common to both options. So as I said, we are comparing the two options, so where these options are similar in nature, to simplify our analysis somewhat, we removed those costs and removed those aspects from our analysis. So sunk cost track work, the new haul yard, things of that nature that are common to both, we eliminated from our analysis. We did, however, undertake a significant number of interviews, workshops, and both in person and by phone with our project sponsors, with the participants in the program, and key stakeholders, as well as our own team and other subject matter experts in the underground and transit industry. So we had initial face-to-face interviews. These were scoping in nature to try and understand what everybody's issues were with VTA. BART, we did a multi-day interview session with BART on the week of March 27th of this year that encompassed security, emergency services, including the fire chief of San Francisco, ventilation operations people, traction power, structural folks as well. We had workshops with, or initial discussions with the two participating design teams, H&TB, WSP, as well as Mott MacDonald, who did the original twin bore design. We also sat down with the City of San Jose, CPUC, and the fire and police departments. We then conducted our risk workshops, which were multi-day workshops and consisted of upwards of 40 people in certain sessions. BART representatives were there throughout, as well as VTA, as well as the design consultants, and a select number of subject matter experts. We then interviewed a series of subject matter experts from other transportation agencies, TBM manufacturers, transit tunnel contractors, and tunnel designers, so that we could get a real rounded assessment of what the risks were, what the consequences might be of those risks occurring. So in those risk workshops, we identified a number of risks. So for twin bore, 127 total, 64 of which were unique to the project and to the twin bore configuration. And for single bore, 121 total, with 74 of those being unique to that configuration. We looked at both risks, which are the green, yellow, red ratings, and we looked at opportunities when they were identified, which are the blue side. The consequence, the likelihood and the consequence ratings are shown here on the slide. I think in the name of brevity, I won't go over it in great detail, but to say only that each risk that was identified in the workshop was given a rating of both likelihood on a 1 through 5 scale, 5 being most likely, and also consequence 1 through 5, 5 being catastrophic and 1 being insignificant. Yeah. And at that point, when we had those number ratings, we translated our model from that qualitative scoring, the 1 through 5 scoring, into a quantitative model. So I'll hand over now to Jim, who can explain what our process was there.
So thank you. This schematic here shows what we took those ratings to, with both implications to impacts to cost and schedule. So you had likelihood and 1 through 5, impacts to cost rated with a 1 through 5, and impacts to schedule rated with a 1 through 5 for each of the risks Bob discussed previously. From that, you kind of up in the upper left, we have our base cost estimates that were for both options that were given to us by the consultants. We reviewed them to make sure they were comparing apples with apples. And then from that, we realized that from each of the design phases, there were certain uncertainties based on what that certain quantities, labor, and materials would cost in the future, and also the quantity variations and the price variations in the future. So that's a base cost uncertainty. To that, there's markup from unknowns that based on the level of design maturity. And from that, the risks that were identified in the workshops were rated and impacted and put into the model and attached to both the cost and schedule models to be evaluated. And what we talked about as a level of comparison is called P80. And that's P80 is a percentage at the 80th percentile. So this graph explains that a little bit. This is a continuum of results from another project. And what it does is, as the model goes through, say, in this case, 100,000 iterations, what it's really sampling is good jobs and bad jobs, and it orders it. So if you have your lower P number results, that means the project went reasonably well. The higher P number results means the project didn't go so well. And by selecting and comparing at the P80 level, what you're taking is a reasonably conservative comparison point between the two projects. So we looked at both options at the P80 level, and if you want to think of it this way, it's 80% of the way towards the worst possible outcome for each option as a point of comparison. Having said that, there's a little. This graph is one of the better ones I've shown to illustrate, or I found to illustrate what's happening as you go through on these big projects from the concept to completion. And what we're comparing here, as Bob mentioned earlier, is two designs at two different phases along this graph. The twin bore option is at the 65% design level, so it's further to the right. It's more unknowns have been recognized. There's more plans developed. There's more budgetary in-depth development going on there. So you're reducing your unknowns as you're moving from left to right. The single bore option is at the 20% design level, much more on the left-hand side of the scale, and much more still to be, I guess the old phrase, the devil in the details. There's still devils in the details that are less known there than they expect to be at the 65% level. So that was part of the analysis going through, is to kind of recognize that and how to compare that. And so how we compare that is by analyzing the risks. And there's two categories of risk involved here, and that's an important concept going forward for you all as you make your evaluations. Is there's technical risk, what we call technical risk, and then there's also financial risk. So technical risk is when you look at a risk, the mitigation is predominantly under the project team's control. It's manageable to a majority extent. So your contingency budget can be reduced when these risks are successfully mitigated. So you're putting that risk is the major influencing factor is your ability to manage that risk. What would be rated as a majority financial risk is where the mitigation is largely beyond a human control. It's a bad event happens and is covered by the budget. That's how that funding is, or that's how that risk is mitigated. So as we went through, we kind of took a look at those because I think that's an important criteria to consider as you're evaluating the two options. And so to kind of give some quick examples, and I've tried to do my best to keep moving here, but the point here is of this graph is when you look at our top 10 construction risks for the twin bore, you can kind of see where the majority ended up, or the minority technical or majority financial opportunities or risk or opportunities. So how many of those risks? About half and half. Half should be managed, and about half are going to need financial capacity to cover. And when you look at the single bore, what you have is your largest risk is a financial risk, but the other 9 of the top 10 are definitely on the technical or management court to mitigate. These are the top 10 construction risks for schedule for twin bore. Again, the schedule is further set with the twin bore, so a lot of the risks there are basically in the financial category, and only one in the top 10 is in the technical category. In the single bore schedule analysis, it's a split. There are also 2 opportunities that were very significant in the single bore that registered there as well. So those would actually be, even in the financial category, there are potential savings to the project that are kind of shown in the blue bars up on the little inset graph there. Now, this ties into a couple of the questions you all had raised earlier. These are some, after we went through all of those risks and categorized them according to schedule and cost and rated them according to likelihood and looked at the evaluations, we recognized among all the people we interviewed that there were certain aspects, other risks aspects to be considered on certain risks. And one was just mentioned about the deeper stations, lengthening the vertical circulation for patrons. I think you all hit upon some of the kind of the crux of the issue. How do you actually frame that issue? And with our panels of people, we recognize that it was mentioned several times, and we took it down as part of the risk register. But it has certain intangible aspects. What is the criteria that you evaluate that? When does it become inconvenient? Is the station because it's deeper, which is what this rating was, or is it because it's dirtier or not clean? I mean, so there was aspects to this that we couldn't put a number to, if you will, and we wanted to present it to you all on these particular issues as stuff that have, like I say, intangibles or other aspects that went beyond cost and schedule to look at. So here's some of the results of our comparison between the two analyses. This is the base cost in 2016 dollars. In the single bore is the cheaper option at the base cost level without uncertainty. when you actually add uncertainty, and this is uncertainty in the variability in price and quantity between the two options, this was the distribution we got for the twin bore option, and this was the distribution we got for the single bore option. And this at the P80 level is the difference between the two. So in this graph, what's happened is when you start putting the uncertainty in costs and quantity, the single bore option is more expensive by $87.5 million at the P80 level, the 80th percent of the worst job. So in the potential risk cost comparison, the twin bore came in here, and the single bore came in here with higher, in general, higher potential risk costs, and this is a big impactor on this factor is where it is in the design maturity level. This difference here at the P80 level was $518 million. Comparing the two schedules, this is the twin bore with a heavy civil completion date. So this is not the completion of the project, and open the turnstile. This is completion of the underground construction portion of the project with the portions that we compared between the two. So this is how they compare head to head in what we looked at in the realm of what we looked at, the underground portion. The single bore across the board finishes quicker, and the delta between the P80 levels is 293 days, or approximately 10 months quicker. So kind of looking at the checkbox comparison, if you go down our assessment, the lower base cost is single bore. When you add uncertainty into it, twin bore becomes slightly lower. So there, the lower potential risk cost is twin bore. The first into revenue service is single bore. And I guess the key takeaway there is we're ready for the track work portion. To turn it over to the track work guys, it's about 293 days, calendar days savings to the single bore. Here's a little bit another look at the numbers with the durations attached to them for the schedule, and the numbers fleshed out for the differences in dollars for the base cost and the total potential risk cost, and where those numbers came from. And so let's finally kind of summary of our findings. The base cost is similar for both options. The uncertainties are included. The uncertainties included are based on the level of design, and that is a key factor in those uncertainties. The two options were basically reviewed and rated based on a contract configuration of design bid build for the twin bore, because it is a 65% design level, and a design build contract model for the single bore. The start of construction is faster for the single bore, getting to the start of construction, breaking ground, if you will. Construction period is shorter for the twin bore. Overall construction is completed faster, however, with the single bore. So just to recap that, the single bore gets in the field faster. The twin bore actually, when it gets in the field, is shorter, but overall the single bore finishes that 293 days faster at the P80 level. All right. And I guess with that, we turn it over to questions.
Okay. Any questions from the board members? Mr. Camus?
While I understand what was presented, there's some factors that I think are important to our city that on cost that are not being thought about, like having our streets torn up for an extra 240 days, and you know the old adage, time is money, and we're talking about our businesses not having access to roads, parking, you know, all kinds of stuff for a year, and I cannot. For me, it's a clear decision, and I just want to be. In fact, I think that some of the construction costs, I don't understand how having all these, to me it looks like single bore has a lot less construction cost too, because you're not doing these cross sections, and you're not doing, I mean, the excavations, and I mean we only did BRT a little while ago on a small section of Santa Clara, and it was I don't know, a year delayed, way over cost. The cost of removing and changing the utilities was astronomical. And I'm having a hard time understanding the logic that these two are going to be similar in cost. Logically, I'm thinking shorter time, easier construction, less room, because it's deeper. We have to change the utilities a lot less. I think, we might run into some more things, and it's not. I know that the design isn't done to where this double bore is. I got that, and I could see where your trepidations are on. We don't know where we're going to go because of the design, but I have to say I'm extremely convinced that the single bore option is the way to go. And I'm not super convinced about the numbers, and especially because they don't take into account that the city of San Jose has to wait for a year to use Santa Clara on the double bore. I know it's not really a question, but it's just skepticism on the numbers that have been presented, quite frankly.
I'll try and answer your non-question. No, it's we did try and capture some of those issues. The utilities in particular was captured quite heftily. There were 8 separate risks that came up in the risk workshop, and those were split down because of the way the cost and schedule worked out into 17 risks in the quantitative analysis for twin bore, and somewhat less than that for the single bore. So I think that the disturbance, as much as we could capture it in the direct project costs, construction project costs and schedule were captured as best we could. The soft costs of surrounding the project, which you're referring to, which is the business disturbance, and none of those costs were considered in our analysis. We were looking at purely at hard construction dollars. So that is something that was outside and beyond the scope, and then also capturing revenue a year earlier, and the acceleration of construction, which reduces escalation costs on those construction dollars, was also outside the scope of our study. We haven't done that yet, but that would be a next step to be done when budgets are put together.
Okay.
The benefits of finishing early.
So none of the money that we're going to receive by going into operation a year earlier has been calculated into that.
That benefit has not been considered in our analysis.
And just to let you know, we actually paid some of these businesses for some of the mistakes, the time overruns, more than I don't know if, am I allowed to say how much? But I don't want to get in trouble with our lawyer. But more than $1.5 million for an extremely small project. This is much bigger. And I don't know if we have any scope of if any of these businesses come back. If let's just say your time overrun comes out, do we have how much could we get sued for kind of estimate out there?
It's probably worth, as you've thrown a number out, it's probably worth re-looking at the tornado diagram, those top 3 risks that dominate that chart. And then it looks like it tails down to nothing. The nothings are actually pretty significant numbers, but the top 3 do encompass pretty substantial risks. The unknown unknowns for the uncertainty on the single bore is a $600 million number. So it does dominate that chart.
The risk of lawsuits was looked at for both options.
Any other questions? Seeing none, then we're going to... Oh, sorry. Mr. Perales, did you have a question?
Yeah, I apologize. I just wanted to see as well if we can clarify something, because what I was reading was that certainly the level of analysis that's been done, as we've said, 20% only for single bore, and what the report denoted was that as that design advances, certainly that's what then minimizes what we have for this risk of unknown risk. That can shift this curve. If we had obviously studied that a little bit further, that could potentially shift the cost, as well as, I guess you can answer that one first, so just that clarification is correct?
That is correct. The reason that the level of design impacts so profoundly at this level is simply because as you add detail, you sometimes add cost. So the additional uncertainty is meant to represent that additional cost and unknown cost. It is something that can be mitigated through tight scope control and other management factors, but you're correct. It would be nice to be able to project ourselves forward in time and get rid of that uncertainty, but unfortunately we are where we are. So that's what it reads.
And then the other one that just stands out to me, and it's in relation, is on slide 125, which obviously does denote within regards to the top 10 construction risks regarding cost. All but one of them are denoted with your M, which I forgot, but essentially on the side of technical mitigation, which is on us essentially, or on the construction of it, the constructor, the designer.
Project team, yes.
Project team.
Yeah, that's correct. Yeah, and the way to mitigate those again is through risk management practices, good engineering practice, and project management practices. Yes.
Thanks.
I have one really quick question here. In terms of this delta between a 65% design, which is where the twin bore is, versus a 20%, which is where the single bore is, how far do we have to advance a single bore design in order to increase our confidence in terms of how these two compare? Does it have to get to the same 65%?
What I would say the way I would answer that is that the two big risks up here are market risk and uncertainty risk. So as you approach your bid point or your bid advertising moment, then you start to get a firmer grip on what those risks might be. So as you look at a design build procurement, you probably would not go to 65% anyway. You would probably look at something a little less than that. So you may be able to get there reasonably quickly. But as you approach bid day, your market risk becomes much more definable.
Thank you. Okay, we're going to move on. So, Mr. Radcliffe, you're going to take us through the comparative analysis.
Okay, these questions have been great, so I won't have to go belabor these points too much. But this is essentially to present staff's analysis about the comparison. This is the comparative analysis part of it, where we compare the criteria for evaluation against the two options. And this is, as indicated earlier, staff's draft recommendation about the tunnel methodology selection. So the way this is broken down is I would like the board to keep in mind that it's best to evaluate the two options in two different categories: tunnel considerations and station consideration. That's the way this is structured. For this slide here, this is basically tunnel constructability. So it's really just talking about the construction of the tube, and just goes through the different considerations we had: what type of machine, what the geology is, what's the construction risks at that location. You know, we have mine cross passages, which is a construction risk. Mid-tunnel ventilation, they both have mid-tunnel ventilation, although the cut and cover activity for single bore is slightly less. It's still a significant traffic impact. It's just not as big and doesn't close the whole street as might the mid-tunnel ventilation for twin bore. Utility relocation is severe in the twin bore at the downtown location, and limited with regard to the single bore to the various mid-tunnel ventilation shaft and the like. Soil volume losses, they're both essentially equal. In other words, the technology, state of the art of the technology is pretty much the same in both. Cultural resources, this is a little almost the same. It gives slightly higher to the twin bore simply because there's so much construction across so much distance to construct the crossover part of the tunnel. And transit impacts, At the west option for downtown, we do impact LRT for the crossover, if I'm not mistaken. So I just want to also say that the utility relocation impacts is associated with the crossover, which is also the cut and cover construction. So in balance, VTA staff believes that for tunnel constructability, single bore has some advantages. With regard to tunnel safety and security, the points of safety are the non-incident tunnel in both cases. They both have separate trackways. They both have ventilation zone approach for ventilation. Even at the crossover, ventilation at the transitions is not applicable to twin bore, but has a single bore there. It has a safety corridor in the single bore. Again, egress is through cross passages at the twin bore and sliding doors at the single bore. However, the next series is interesting because the number and location of the cross passage is primarily dictated by geology and access from the surface, and that produces 33 cross passages in the twin bore, whereas in the single bore you don't have that constraint, and you can have 51 side-by-side cross passages. In the single bore, you also get 25 additional cross passages that have stairs for a total of 76 as compared to a total of 33. The durability, this is a function of new requirements for fire and blast events in the tunnel. We didn't have that same requirement. A twin bore would have to be reviewed, although it would certainly be able to accommodate that, and in the baseline assumptions for single bore, they're included. There is some, it says passenger familiarity for tunnel safety. So the thing here is that, there's a protocol for evacuating the trains. It's on all BART cars showing you how to and when to evacuate in certain circumstances. And with the twin bore, it's pretty much the same everywhere else on the system. In the single bore, it would have to be unique, so that's some passenger familiarity issues to be considered there. But in balance, primarily because of the cross passages, we believe that the single bore has the advantages. With regard to tunnel operations, they both have separated trackways, separate by bore in the twin bore and by wall in the single bore. They both have tracks running side by side, except the single bore has some locations where the track is either in transition or in stacked. Crossovers, there's a difference here in the twin bore has the crossover directly adjacent to the passenger station, and that would aid in turnbacks, although I'm not certain how often that occurs with BART typical operation, but it certainly would be proximate to the station. And in the single bore, it's a little distant from the station in that you have to make a transition to affect that crossover. The single bore has some runtime advantages than the twin bore, 8 to 16 seconds depending on where you are between Alum Rock and Santa Clara. It is possible to configure the single bore with an additional crossover, but not possible, or certainly not practical with the twin bore. And I think we already talked about the Silver Creek fault and the adjustment of the line. So in this case, we believe that for tunnel operations, the single bore provides the most advantages. On the tunnel maintenance, the track and systems are essentially the same, although they're configured differently. The ventilation types are essentially the same, although some of the equipment's different. Some of the access for maintenance is different. Ventilation facilities are essentially the same, except some of the ducts are a little bit configured a little bit differently. The ventilation equipment, they both have mid-tunnel ventilation facilities. The twin bore doesn't have enclosed spaces in the tunnel, and that's a maintenance item with regard to the single bore, in that you have volume inside the single bore tunnel that is not specifically assigned to a particular activity, and you've got to be careful not to enclose spaces so that you are hiding what might be a maintenance requirement behind the wall, so to speak. You also have to provide access to all those areas. So there's some maintenance considerations on the single bore that are not manifest in the twin bore. Groundwater intrusion is kind of the bigger one. We believe that as compared to the single bore, the twin bore would present a higher level of groundwater intrusion than the single bore would. although what water is introduced does not have to be pumped to the surface as high, although this is a marginal difference, 70 versus 90 feet. Another major thing for maintenance is worker familiarity. So again, personnel that are performing the maintenance would have to be specifically trained on the single bore configuration, although I don't know how often maintenance personnel are moving from one station to the other. I would suspect there's a fair amount of that. And maintenance worker access potentially could be better in the single bore depending on how it's configured. So from a maintenance perspective, staff believes that these are kind of equal. It depends on, a lot of factors here that, we can't really evaluate very effectively. Comparative analysis for stations constructability. Again, this is cut and cover, so I won't go through a whole lot of this. It's primarily dominated by the impact to utility relocation, traffic disruption, and the like. So staff believes that for constructability, stations constructability, single bore has the advantages. For safety and security, again, the freeze zone issue at the concourse is under review, so the design may need to be reviewed for twin bore, although I'm sure it can be configured to satisfy, and it's included in the single bore design. Point of safety, we believe that the location of the concourse in the single bore provides a slight advantage insofar as the moment the passenger steps off the platform into the adit, he has entered the point of safety. And at the twin bore, that point of safety is at the top of the stair or escalator or elevator to the concourse. The open stair escalator is not really a safety security issue so much as we would be designing head houses that potentially could be closed so that stair and escalator entries from the sidewalk, for example, are not open overnight when the system is not running. We talked about the free concourse area. For stations, we believe safety and security has some advantages. Also, the nature of the monitoring of the entrances, them being sort of concentrated in specific facilities rather than a whole bunch of smaller ones, may make it simpler to monitor the activities inside. So again, staff believes that for some safety and security, single bore has some advantages. Passenger experience. This is a very difficult one. It's a very important one. Passenger experience relates to platform depth, as we've talked about. It also relates to familiarity. While this station is quite different from other stations on the system, and that may create some positive or negative reaction from the passengers. Again, the longer elevators and escalators are part of that passenger experience. There is a potential for high-speed elevators at the single bore, and that could contribute to positive passenger experience. There is a key difference on ADA access. I think I mentioned it earlier, where in the single bore you can access the platform from inside the paid zone, so it's a one trip to the passenger platform by elevator, whereas it's two with the current configuration of twin bore. Again, passenger familiarity we talked about, and access from both sides of the street. Twin bore has an advantage there. So for comparative analysis on passenger experience, and particularly because it's such a subjective criteria, staff leaves this as they're essentially equal, and would leave that to the board to consider whether they agree with that or not. Comparative analysis for station operations. The unobstructed width on the single bore is quite larger, and that's important to train operators. They can see the location of passengers as they approach the platform. It's also for remote monitoring. You can see unobstructed the entire platform, although the adit would have a separate a camera, if you will. Whereas on the twin bore, there are a lot of negative spaces under the vertical circulation elements that create multiple instances that have to be monitored. And from a station's operations, that's how many people are waiting kind of a thing. The surge at the Diridon platform, although this is a pretty conventional station plan in the twin bore design, it could be reviewed to add expansive concourse to deal with the surge, and certainly that can also occur at the single bore. Quite a larger number of vertical circulation elements would require more escalators in the single bore. Accessibility we talked about, staging agents I believe we talked about. Egress to the free zone. Generally speaking, the twin bore design has emergency stairways at the end of the platforms that go up a level into the concourse, which would be the paid zone, and then on to the street. Sometimes when they're in non-emergency circumstances, if that doesn't go to the paid zone, it could be an opportunity for fare evasion. And in the single bore design, it's a little more challenging to accomplish that, and the emergency stairs could be an opportunity for fare evasion, and that would have to be addressed from an operational perspective from monitoring and policing. For station operations, just because of the clearer and simpler platform design on the vertical circulation being outside of the platform area, we believe that the single bore option has the most advantages. On the station's maintenance, the vertical circulation elements in the single bore are multiple and longer. The ventilation is similar. The facilities, the interiors are concentrated, but they are larger in terms of volume. The facilities on the twin bore have, for example, head houses, and the single bore is an enclosed structure. Perhaps the single bore is a little more, might be a little simpler. The groundwater intrusion is a serious maintenance consideration, and with this twin bore you have a lot of dissimilar materials and a lot of opportunity for water intrusion. That becomes a maintenance item in two ways. One is you've got to clean and keep the surfaces that are affected by water intrusion in a state of good repair, and also that you have to keep the pumps in a state of good repair, and that's a major maintenance item. The high-speed elevator, I think, is something we want to explore just to deal with the passenger experience. We think it would be a positive. You cannot do that with the twin bore. Platform edge doors we didn't really talk about. The single bore may require platform edge doors to facilitate the fire and ventilation control. May not, but if it is, it's a new system. It also has some benefits to the passenger experience. Maintenance worker familiarity, again, single bore being unfamiliar. So from a station's maintenance perspective, we think this is about a wash also. In other words, they're essentially equivalent. On the comparative analysis for economic impacts, certainly the detriments are severe for traffic disruption and utility relocation and the like on the twin bore, and not so much on the single bore. On this particular item, this is a interesting question, not so much on the economics, but just in general. The construction period is short relative to the life of the system, and that should be a consideration for the board. However, the impact, it being short, is impacting those who are most proximate to this decision making. So there's some altruistic aspect about how much sacrifice we all want to make for the future generations. So that's one way to look at it. But nevertheless, the detriments for twin bore are mostly related to the cut and cover construction. They essentially have an equal transit benefit in that they serve the community equally well in terms of transit capacity. Transit integration, I think, is primarily at Diridon and probably are about equal. And with regard to the vertical circulation elements being off-street and being essentially more like a building, I think it presents a much better benefit for joint development and integration with the transit system to the commerce at the street level. So for this reason, we give single bore the most advantages. And with regard to comparative analysis on cost, I think our ALDEA experts have covered this very well. I just do want to address the potential risk costs because this has come up quite a bit. You can see that even in the remaining work to be done on twin bore, there's $780 million worth of risk as analyzed here, and a much larger figure, about $500 million more for the single bore. And I just wanted to give one concrete example of how the advance of design would reduce that $1.3 billion, excuse me. So, for example, in the twin bore design, we had already selected the elevation of the alignment through the geology. And to analyze our risk in that, we did soil borings and soil sampling all throughout that alignment down to that level. And so we have a very good characterization of the geology in that area. The single bore is deeper, and we didn't put our bores down that far, so we don't know what's down there as well as we know what's above. But we can make a reasonably good inference. But that is a risk because it's an unknown. It's a known unknown, and in the risk analysis there are some risk values for that. But they will completely be eliminated by boring down deeper and validating what that is. So even though there's risk amount in terms of cost in the 1.3, it very well wind up being zero when we get to that point. So that's one example. And all of those risks have different characteristics in that regard. So on the operating and maintenance costs, the single bore forecast is about a little under 3% higher than the twin bore. But that figure, 3%, is generally at or near the accuracy of the estimating in this regard. So that's about a wash. But the schedule duration, as indicated before, is about 10 months, 9 to 10 months sooner on the single bore. That could have a value of about $50 million. And overall, we consider the cost to be essentially equal, even though the potential risk numbers are a little higher for the single bore. So in summary, here's what I just went through. You can see that in every category of consideration, at least with regard to VTA staff opinion, the single bore is either equal or superior to the twin bore. And this is the nature of our draft recommendation for the single bore. I'd be happy to answer any questions.
Okay. Unless somebody has a pressing question, what I'm going to ask that we do is I'd like to say thank you very much. Trying to keep us moving here. So, Bart, I would like you now to join us at the table. I don't know. Bob, do you have any slides? Okay. So I'm going to have Bart join us. And so, by way of introduction, we have here is Bob Powers, who is the deputy GM of BART. Wave your hand, Bob. And we're going to get name tags in front of everybody. We have Bob Mitroff, who's the Chief Planning and Development Officer. Oh, there you are, over in the corner. And then we have Tamar Allen, who's the Chief Maintenance and Engineering Officer. And lastly, we have Bernie Smits, who's the Mechanical and Ventilation Manager. Okay. And so what I'm going to do is I'm going to ask Bart to take some time and go through what they would like to and comment on what they would like to, and then we're going to open it up to questions, and I'm assuming that some of the questions we're going to probably want to have both BART and VTA staff probably answering some of the same questions. So take it away, Mr. Powers, and welcome.
Thank you. Thank you. First, let me just thank Chairperson Bruins and members of the VTA Board. I think it's a very important topic and a very important decision that we have at hand here, and I appreciate the invitation to come down here with the BART team and talk to you about this topic. Secondly, Nuria, General Manager of VTA, I wanted to thank you personally and your staff, Carolyn, Dennis, Mr. Davey, and boy, what an impressive team of consultants that you have pulled together to pull some of this work together. That was a very thoughtful presentation. So again, thank you for that. It's been a good partnership, and I look forward to working with you as we continue down this road. So I'm going to make a couple of opening remarks at a fairly high level. Then I'm going to ask these three folks to my right, Barney Smits, Tamar Allen, and Bob Mitroff. So together, these are BART employees, and together they have over 75 years of experience operating, maintaining, providing engineering excellence to BART. This is not a consultant team, or these are people that direct the work, that are out there doing the work. So, and we have some concerns with some of the information that has been shared today, and so we wanted just to put them on the table as we continue this discussion. Just a little bit of background. I think you all know, and I'm not going to get into too many details here, but BART owns, operates, and maintains arguably one of the most successful heavy rail lines in the United States. We're north of 40 years old. We carry about just south of about 440,000 passengers a day. And our success in our fare box recovery is second to none in the United States. And the reason is, one of the reasons is the dedication and the experience of our staff that work the system. Day in and day out, these folks are out there working the system. They know what it takes to operate a light rail system. And what we're talking about is moving people safely and moving a lot of people. That's light rail. Heavy rail, sorry. So I think the issue at hand that we want to make sure that BART conveys, Chairperson Bruins and board members, is that this is a 100-year decision. We've heard a lot on the construction impacts, and those are very important, not only to the city of San Jose, the Santa Clara County, but to BART, to VTA, to all of Bay Area. So absolutely, the construction impacts on the construction, the technology are very, very important. But also, I would like us to keep in mind, the investment of this project is approximately $5 billion. It's like 4.79. Let's say $5 billion. But there's a bunch of other tangential investments, projects that are going in the region, that are adjacent to this that we should keep in mind as well. We have the Fleet of the Future coming on. We have our train control. We have the high-speed rail project that will be coming into Deardown Station. We have the Caltrain electrification. There's a lot of projects that are going on in the transportation network that are also part of this not directly but indirectly, this $5.5 billion investment that we should keep in mind. Another point, and you all know this, is San Jose is the largest city in the Bay Area, largest in size and by population. And we want to make sure that the right decision is being made with that in mind. Furthermore, San Jose is the gateway, the connection, or some people would say is Silicon Valley. Some people that might be a little bit bold, but it at least is the gateway to Silicon Valley. And what BART will be able to do, if we get the decision right, is connect the people from the housing to the jobs. That's what BART is going to be able to provide, and that this is a 100-year decision, and we just want to make sure that all the information is out there for this board to take an action on, as well as the BART board to take an action on. So just let me give you an example. The city of San Francisco, our ridership in the last 5 years has increased 100,000 riders. Last 5 years in the city of San Francisco. And so what is it that unreasonable to expect that type of ridership might happen over the next 100 years? That's the investment that we're talking about in the city of San Jose. It is poised right now to be, really the mecca, of Northern California with Silicon Valley and its connection to everything else. I mean, it is it's right there. So I just want to make sure that as we have this discussion, the broader context is taken into account. So from my perspective, I think the VTA team has done a very, very nice job in answering the question, can a single bore be operated? And the question is, and we've written the general manager a letter, BART has, that we're not questioning that. I think you've done a very, very nice job, VTA, on a fatal flaws analysis that a single bore can be operated to some extent. You're going to hear a little bit about fire, life safety, ventilation, and ADA from our technical experts here. But at some level, a single bore, technically, yes, it's feasible. It's feasible. You heard from VTA's consultant experts here. Sure, you can design and build it. But is that the right project? Short of the construction impacts, and I know those are very severe. And I know that they're very important to everybody around the table here. But there's other areas or other filters that we ought to also be looking at. We should make sure that we keep in mind, when VTA and BART has met several times on this topic, and there's different types of construction impacts. Certainly there's the utility impacts that were talked about earlier. Get that. They're somewhat covered in the work that's been done by LDA. The second one is the light rail operations. There's 2 light rail lines that cross Santa Clara there, and we get that. I did a little research on my own, and roughly there's about 25,000 trips that cross that, that run on those 2 rail lines daily. Not every trip is crossing that screen line there, so it's somewhat, maybe it's 20,000 trips that would need to be accounted for there. And then certainly there was a discussion here, the small business impacts are critical, and we need to do what we can to keep the small businesses held harmless, if you can use that, if I could use that term, as we go forward with this. But also, that's on the construction side. But on 100 years, we want to make sure that the fire life safety, council member or board member Chavez brought that up, you know, the fire life safety issues on point of safety, you're going to hear about that. You know, BART has a completely different perspective than what was presented here on the twin bore with the street being a point of safety. But when something happens, it's not just one thing that happens. You can go back to any transit catastrophe that's happened. It's never a single isolated incident. It could be something going wrong with it could be human error, you know, from the passenger side, or something went wrong. Could be ill will, somebody ill will. Could be mechanical. It could be not knowing how to operate a ventilation system properly. So it's never just one thing that goes wrong, and we want to make sure that this board is tracking that, and that my board, the BART board, is tracking on that. We had some discussions about that in Barcelona when we were there, about the intricacies, and if something happens, it's a lot of stuff is going on, and simple is better, especially on point of safety and getting people out. Second is the ADA. You know, we didn't really talk this morning about ADA access and ADA getting people with disabilities in and out of the system. It's a big point. I think a memo that we sent to the general manager, I think about 12% of the population here is ADA, or, you know, this one type of disability. But in 20 years, it's going to double that. It's going to be 24, 25%. It is a very important issue for us in the transportation professional to take into account, because this is not a 2, 3, 4 year, 5 year decision. It's a 100-year decision, and we want to make sure that we get that right. And then, you know, on the comparative analysis, I think BART just has a different point of view on what VTA staff has listed out there for you, and so you'll hear a little bit about that from tomorrow as we go forward. But look, I just want to make sure that I'm very clear. BART is committed, Chairperson Bruins and General Manager Fernandez, to working with VTA and the board down here to get to the right solution. We have been there at the table, and we're not going away from the table to make sure that we get this solution right, and that's a commitment from BART. And then the other thing I want to make sure that you understand, and I'm going to make it very clear to my board, is you need to make sure that you understand the trade-offs. A perfect example up there, the comparative analysis. What are the trade-offs associated with each of those? If we go to a single bore, if we go to a twin bore, what does that mean, and what are the trade-offs, and what are the consequences of one or the other one? And I think that's some information that that is missing on this. But you as elected officials, and my board for sure as elected, providing the trade-offs on either is going to be critical moving this thing forward one way or the other. So with that, I'm just going to turn it over to Bob Mitroff to walk through some technical points, and then we'll move to Tamar and to Barney.
Microphone working? Okay, very good. I'm here to comment on ALDEA's comparative analysis risk assessment. I thought it was a very interesting study, and I'm sorry to say that we did not have enough time with ALDEA to gain a full understanding of all of that study's findings. We spent most of the 3 hours that we had with ALDEA at the workshop a few weeks ago debating what was not in the study. What we were expecting, what we were promised, was a comprehensive apples-to-apples comparison of all the parameters that matter to us on a qualitative and on a quantitative basis, especially those which applied to passengers' safety risks and engineered points of safety. There were no risk simulations done on any of those. The one main finding of the study that we do not dispute is that there's a significant upside cost risk for the single-bore alternative. The range of cost impacts for the top 3 cost risks, those being market risks, unknown unknowns, and owner delays, showed that for single-bore, they range from $440 million to $1.8 billion. Now, the statement was made earlier that a lot of these risks could be mitigated away. That remains to be seen. One thing we do know is that the market risk is a significant factor here because there are only a handful, less than a handful of firms that could do a 45-foot single-bore tunnel, whereas there is a many multiples of that could do twin-bore drilling. It's that much more conventional. Bottom line, the cost risks for single bore are significant. When you add the uncertainty elements and the risk elements, the number you come up with is $600 million at the 80% risk level. It baffles to me why this finding was not included in Aldea's summary, nor how you could say that the findings in your comparative analysis on costs were equal. The second area that the schedule looked at was schedule risk. We fundamentally disagree with Aldea's finding that the single-bore alternative enjoys a scheduling advantage over twin-bore. Twin-bore, again, is at 60% or greater level of engineering. Single-bore is at 20%. And then the additional assertion is made is that design build is going to give you a scheduling advantage over design bid build. I've been at BART for 25 years, and we've expanded in my time there from 71 miles to 109 miles. We've built projects using both methodologies, and our absolutely firsthand experience on this is that you might get a little bit of a scheduling advantage on the fairly simple civil work that gets done at the front end of the project, but you lose it all and then some on the highly complex, owner-specific systems integration work that always holds up the startup of a project. When you add to that the complex training that you're talking about for single-bore stations, I do not agree that is going to have a schedule advantage over the kind of system that we've been built and operating for 45 years. Lastly, the O&M cost estimates are very rough. We sat down with VTA staff early this week. There are significant refinements that need to be made to that. We need to get the cost factors agreed to, recalibrated, and then get a more accurate estimate of that. But we do not dispute the comparative finding that the single bore will in fact cost more than the twin bore, especially in regards to the additional ventilation energy costs, the escalator energy cost and maintenance, as well as the additional staffing that the multiple station agent booths will require. Lastly, I just wanted to echo something Bob said earlier. If this is a 100-year investment, why would you want to limit yourself to such narrow platforms, especially at stations like Diranon, which are going to be handling event traffic? Narrow, single-direction stacked platforms are clearly not preferable in our 45-year experience to a wide single-platform station. I thought it was kind of misleading when you showed the picture of 19th Street Station and you showed the obstruction of the escalators and the narrowness of the platform. That wasn't the platform that twin bore would have. That was the lower level half platform at that station. The platform that's analogous to what we would be building at your stations is the upper level wide platform with trains going in both directions. So with that, I'm going to introduce our Chief Maintenance and Operations Officer, Tamar Allen.
Hi. Thank you for having us today. I really am pleased to be here and have an opportunity to talk with you. I have 35 years of experience at BART in operations and have been involved in the onboarding and maintenance of all of the extensions. There's been a lot of work done to date with some level of partnering and collaboration between the two agencies to look at the issues that are critical to the decision of whether we should build a single bore or a twin bore. I would say that there are still some significant concerns, and that the intangible are, as they were represented earlier, are very important, and that we owe it to the riders in Santa Clara and San Jose and the larger Bay Area to make sure that we do due diligence and that we understand the ramifications of all aspects of a decision that we would make and what the long-term impact would be for the region. Most specifically, I have concerns with emergency egress in the transit industry and specifically in heavy rail transit where we're carrying a lot of people. There can be nothing more important than safety. And when we're building something that's going to last hopefully a lot longer than 100 years, we need to make sure that we get safety right, because the ramifications for the rider will be pretty severe if we don't. The depth of the single bore requires the installation and maintenance of more vertical circulation, elevators and escalators. And beyond the added maintenance requirements that come with that, this creates safety concerns. By code, in the event of a fire, escalators must stop and elevators must return to a pre-programmed floor and turn off, which means that people exiting have to climb the escalators or stairs as though they were stairs. This creates a serious impact on station exiting capacity because the flow of those passengers in reality is only as quick as those passengers, including passengers with some limited mobility, can get up those stairs. An operational issue also exists in the stacked configuration. And the issue is when you have to do a train-to-train evacuation, and when the conditions are such that that evacuation necessitates that the rescue train be in the opposite tunnel, we have to move the passengers from the problem tunnel to the rescue tunnel. And when you have stairs involved with mobility limited people, you have complications and you have problems. And in the stacked configuration and in the transition to the stacked configuration, we're concerned about those issues. In the single bore, and you saw earlier in the presentation, in the single bore construction, there are 76 emergency egresses between the two tunnels or the two trackways in the single bore configuration, and 51% of them are at grade. But I would encourage you to look at the alignment drawings for the configuration. There are extensive segments which are stacked, and in those there are 25 egresses between tunnel and tunnel which involve stairs. There's also a concern about first responders, and when you can have a designed point of safety, and Barney's going to talk about our concerns, which are very legitimate and very real around the proposed designed point of safety. But even if you have a designed point of safety, human nature is such that people are going to head up to get away from the problem, whether it's a fire, active shooter, a terrorist event, a breakdown, whatever it is, people's nature is to get away from it. And so you have two entrances with people coming out of the entrance. And at the same time, you need to get first responders down to help people with mobility issues and to deal with whatever the problem was in the first place. And you have an impediment to their travel to the instance, which concerns us. Operationally, I'm also concerned with customer interface and general access to and within the station. The single bore configuration provides for two unconnected entrances. The lack of a shared concourse level limits crowd management, which we use and I think will become an issue at Deardan for events. It complicates policing and it necessitates hiring more staff. The single bore configuration will require the use of higher capacity elevators. It's our experience that in urban environments, controlling the social issues around use of the elevators is very complex and expensive. As a matter of fact, we are now contemplating the use of elevator attendants in some of our stations, and I think that we need to consider those factors as we're building this station and, you know, what are we going to have to invest to maintain these elevators as we put more in. The single bore configuration, there's been some discussion already about the just over 15.5-foot platform for the single bores compared to the 28-foot wide center platform for the twin bore. In the longer term, as the region grows and as we see the type of growth in the San Jose area that I would expect would occur with the addition of BART, the single narrower platform will hamper crowd management. And most specifically in Deardan, but as you grow, those impacts will be experienced at other stations. Maintenance issues associated with the single bore ventilation are important, not only in that I think you're going to hear from Barney, we have some fundamental disagreement in whether the ventilation is actually equal for a single bore as to a double bore, but also in terms of the impacts on the neighborhood that we operate in. And most specifically, we, the maintenance people at BART, are in the tunnels every night. And we go into those tunnels using diesel equipment. And in order for our workers to safely do the work that they must do in those tunnels, we have to run the ventilation system. And it is our experience as TOD has been developed adjacent to our stations, and I noted that at several of the stations on this alignment, we're also looking at TOD development, that we receive significant neighbor complaints about the noise generated from the ventilation systems. And we simply cannot do the work that we have to do without the use of those ventilation systems. As operators of a busy, heavy rail transit system, our primary concern, as I said earlier, has to be safety. The things that we're concerned about aren't figments of our imaginations or supposals of what could go wrong. They are things that do go wrong in our business. And recent events in this country and abroad demonstrate that we need to take the safety concerns and the evacuation and movement of our passengers very seriously. In WMATA, where there was a smoke incident in a tunnel, there was a failure associated with the ventilation system, which resulted in the injury of many passengers and 1 fatality. Recently, we saw the bomb in London. We've seen terrorist activities in other transit systems. We saw how passengers responded there, how they've responded in Madrid, how they've responded in Japan. We have some understanding of what we need for egress and what we need for a point of safety. And our passengers will seek the street, and we need to make that accessible to them. I appreciate the time that you've allowed me today. I'd like to introduce Barney Smits, who is one of the transit industry's leading experts on fire, smoke, and ventilation.
Thank you for giving me the opportunity to speak to you today. Barney Smits. I'm BART's manager of mechanical engineering, and my expertise is on tunnel ventilation and fire protection systems. I'm a licensed professional engineer and a former member of the National Fire Protection Association and Society of Fire Protection Engineers with over 20 years of experience at BART. Tunnel safety and emergency ventilation. I'd like to address some of the points about tunnels, stations, emergency ventilation, fires, and safety on this project. Tunnel safety and emergency ventilation are difficult but critical issues. Emergency ventilation must respond immediately and direct smoke away from passengers so that a safe egress path can be established. The 2015 fire on the Washington Metro's L'Enfant station resulted, as Tamar indicated, in 91 injuries and the death of a patron. Most of this was resulted from improper use of the tunnel emergency ventilation system. During that investigation, the National Transportation Safety Board documented that BART's emergency ventilation system and operating procedures were a national model for other agencies throughout the nation. BART's emergency ventilation system utilizes multiple sources of power to address the concern. However, the loss of power to any emergency ventilation system is a significant risk. BART minimizes this necessity of constant power to an emergency ventilation system by providing adequate exiting to the surface. As opposed to some of the other comparisons that you've seen of the stations and systems that are operating, BART does move 2,000 people, and our trains are significantly packed. One of the examples that was presented was the San Francisco Muni. Even a fully loaded Muni train is going to be about 400 people. So BART's literally running 5 times as much. And that's a significant risk that we need to keep in focus, because a large quantity of people is much harder to move, much harder to get out, and much harder to keep safe. So first, tunnels can be dangerous. Access, egress, and emergency ventilation are critical to providing safety in tunnels and stations. The emergency ventilation system in the single bore design is complex and difficult to operate. It is not the same as the BART system. Regardless of the emergency, derailment, earthquakes, fires, floods, active shooters, and active terrorism, BART's goal is to get people to a station so that everyone can exit safely to the surface. The public way or safe location outside the structure is one definition in the California Building Code of a point of safety. That's outside the structure. The California Building Code establishes that there shall be a significant means of exit to evacuate patrons from the station platform in 4 minutes. We've heard that number today. And to a point of safety in 6 minutes. The executive summary presented states that the single bore design because of its depth, cannot meet the California Building Code requirements to exit patrons to the surface. While the executive summary alleges that the twin bore station design could not meet the California Building Code, BART respectfully disagrees. As during the 20% design and the 65% design reviews, BART worked with VTA staff to clarify that additional mid-concourse entrances would allow full compliance with state and federal requirements for several decades. BART fundamentally disagrees with the consultant's view on emergency ventilation and the requirements for a point of safety. BART prefers, BART uses, BART has the surface as a point of safety. Second, besides proper exiting, access to emergency personnel and first responders is critical. The shallower depth of the twin bore design allows quicker exiting and provides more exit paths than the single bore design, and allows first responders superior access in an emergency, without which patron injury and death would likely occur. Third, a fire within the station at the concourse in the single bore design requires an additional emergency ventilation system. The single bore stations have two main exits which function like chimneys, pulling fire up them. A fire in one of these single bore entrances can significantly reduce station exiting capacity and increase patron injuries and death. In single and twin bore station designs, emergency exits are separated from the standard main exits. In these exits, if these exits are positioned too close together, then even a medium-sized fire can cause several exits to become unusable. The single bore design has exits that are too close together for safe exiting. Fourth, structural damage from a fire can be a problem. For the single bore design, because of the stacked nature of the single bore stations, a significant fire at the lower platform could cause structural damage to the upper platform track slab and significant risk to the patrons, causing the entire station and potentially that portion of the system to be out of service for an extended period of time. Finally, flooding of the tunnels is also a concern here, and a final reason for providing proper exiting. The proximity of Coyote Creek, the Guadalupe River, groundwater intrusion after an earthquake are additional reasons for providing multiple and shallow exits to the surface, available only with the twin bore design. BART is interested in working together to find the safest and best design for San Jose and the entire Bay Area. I'd like to thank everyone for their time and consideration, and the BART team is available to answer your questions.
Okay, so in terms of a process check, I think what I'm going to ask is, you guys, thank you very much for your presentation. You raised some key questions that I'm sure the board would like to get some responses to. So can I ask that staff, could you address some of the points that were made, or you or the consulting team?
There's an awful lot there. I would like to just talk a little bit about the emergency point of safety and the vertical circulation from the twin bore. Our computations after reviewing the twin bore design based on the design criteria provided by BART of a full passenger load of 2,500 passengers in the train, fully loaded train, indicate that the passengers cannot reach the street level in 6 minutes unless additional vertical circulation elements between the concourse and the platform are added. Adding additional, that is 3 vertical circulation elements, adding those will necessarily reduce the platform width and what platform's area, and the width would have to be widened to recover that to achieve other standards. In the city of San Jose, we're already constrained in the street right away. As I said earlier, those streets are not as wide as in San Francisco, and we have not performed analysis as to how that might work, but it would most likely extend beyond the street level into the sidewalks, which may create some impracticality. The twin bore design would therefore necessarily require a engineered or designed point of safety at the concourse level, as I had previously indicated, which is certainly compliant. And as I previously indicated, there is a difference between the single bore design and the twin bore design in that regard. The twin bore design is a shorter distance inside that point of safety to the street surface than the single bore design. In terms of reliability, multiple sources of power are typical among all the options here. And the design of the ventilation system inside the tunnel for maintenance is certainly of concern. I think I may want to have Sean address that, if you don't mind.
Thank you. With regard to the occupancy of trains, we did do our analysis with a higher occupancy. It was felt at the time that we started our analysis that this was an appropriate thing to do to make sure that this was a viable solution for out to 100 years. That is a difference between the previous design and the lower station. It does present a challenge because the occupancies of the station get to a point where, as was referred to earlier, the width of the station is a constraint with the edges of the street. So there's a challenge to get enough egress width capacity up the stairs into the concourse. This challenge is addressed with the single bore concept because we have a lateral exit with a passageway that's quite wide. And I think if you noticed on the slides, there is queuing that's formed up at stairs from that vertical circulation concourse. But what you may not have noticed is there's also opportunities to put in other stairs in that particular vertical circulation concourse. And we didn't fully explore all of the opportunities to put in additional egress stairs. And I quite agree with the points being made that you have to have a system that's resilient and it has a lot of capacity for self-evacuation. Self-evacuation is one of the key ways that we can provide safety for people in the station, and that's not up for debate. So.
Of comments also, in terms of references to.
Can I get your microphone closer?
In terms of 65% design level for the twin board, as you can see throughout the presentation, there are a lot of issues with code compliance. Codes developed since 2008, and FTA requirements developed as well. So this percentage has been addressed. In terms of power sources, reliability, and that also ties with Ishave's question. Each station is designed to the code, so there are multiple sources of power. Actually, two independent sources of power for all systems on which fire life safety depends. There is also an UPS, uninterrupted power supply, that will be provided. Thanks. In terms of twin board, and there are a lot of questions. I made like 4 pages of notes of potential questions that came, and we would love to respond to all of these questions in writing. But in terms of, just a couple of points, in terms of twin board meeting BART facility standards and NFPA 130, we have to remember that passenger forecast 2035 is during normal operation is different, and the crash load in emergency is 2,500. It's not 2,000. There are also different criteria that have changed in emergency that Sean has gone through. While applying these new train crash loads to the with the new codes and standards, we absolutely could not, with our analysis, satisfy BART, BFS, BART facility standards requirements in terms of clearing the platform in 4 minutes and reaching the point of safety in 6 minutes. We also tried to apply 2,000, let's say, previous passenger crash load, applying new criteria per codes and standards in terms of passenger travel speed, queuing criteria. We again could not meet 4 minutes criteria for clearing the platform and 6 minutes criteria to the street. Even looking 300 feet criteria in terms of maximum distance from the farthest point of platform to the concourse level, considering the concourse level is a point of safety, but beyond the fare gates, that criteria could not be met. So there are issues with meeting this criteria. Even for twin boards, this design need to be revisited. And wherever we looked at, we came to a conclusion that point of safety need to be provided at a concourse level. And station emergency ventilation need to act such a way that tenable environment exists throughout the egress path, through the concourse level to the street. So there are many issues, and we identify those issues in the memo. We can have a separate meeting with BART to go in details through all these issues to every single point. There are so many of them. But we would, at this point, we stand in terms of our conclusion that a single board as designed right now fully meets NFPA 130 requirements. And as we noted, BART facility standards refer to California Building Code, and California Building Code adopts NFPA 130 without comment. So this is something that we all need to recognize. And there is a complete different discussion in terms of way of operating, preferences, and so on.
Okay, I'm gonna take control back over here. The discussion that needs to take place at this point in time is really kind of the meat and potatoes of a lot of this. And this board is working toward a goal of making a decision in October. Okay, and so I'm going to throw out a suggestion here. Okay, one is people have other commitments today. The public also, we're kind of expecting us to be able to wrap this up at noon. So what I would like to suggest is, I think what we need to do is, I think BART and VTA staff with the consultants, I think they need to schedule some time and identify each of these issues that were recited today. Thank you very much. We need to get those kind of written up. We need to go through and have a response to each one of those. And I would have a third column, which is what are the alternatives? I mean, ways to work around them, versus saying this is black and white. Is there a compromise? Is there something else that can mitigate or deal with the issues? Because I think, the issues, I will treat every issue as being real until we can prove otherwise, or we can try and figure out how to mitigate that. So I think that should be a step that we need to commit to. And then we have two choices for the board. One is, if we want to stay, and maybe staff can chime in after I put this out there, we're scheduled for our October 5th meeting to make this decision. but we could look at scheduling another special meeting, which will take the work product that comes out of this and present that to the board so that we can finish this discussion and get all of our questions in addition added to this, and then stay on track for the October 5th board meeting. Or option number 2 is we look at using the October 5th board meeting as a continuation of this, presenting it at that time to us, and then having a special meeting after that in which we would actually make the decision, okay? Because I don't believe we can put both of these into the October 5th meeting. So it would be saying that we would be committing ourselves to an extra meeting, and whether we do the extra meeting before our next board meeting or after, or at that meeting, and then the special one being the decision making, I think staff needs to help us understand how much time. But before you do that, I guess, can we get general concurrence that that makes sense for all of us? Okay, because this is huge. Okay, so if we have that now, staff, could you comment on the timing?
What you asked. So to do a special meeting, Bob and I both agree on this. I think anything before October 5th is going to be tight. So just because we want to make sure that we both vet it, we both understand where what the discussions are, be able to review anything that needs to be done. So I think we would recommend to come back at October 5th to discuss it, and we will figure out, we'll meanwhile work with our environmental staff and FTA as to the schedule and what we might be able to accommodate and keep you posted on that. But I think we would need to come back October 5th. I don't think a special meeting in between we would be ready to come to.
Okay, then why don't we, if I'm hoping that Bart's got that flexibility.
Yes, we can. I will work. I'll commit to you, Chairperson Bruins and Nuria, GM. We will work with Carolyn. We'll be ready to come back on the 5th if that's the board's decision here. And what you're asking for is to flush out this comparative analysis is what you're asking for. And so we're ready to do that with Nuria and her team and Carolyn, and so we're committed to doing that.
Okay, so what I'm going to say is that we're going to go shoot for October 5th to incorporate that into our board meeting to have the wrap up of this discussion, and then staff will then be pinging all of us to see when we can schedule a special meeting, assuming that we do need to make a decision in October to keep us on track for the March ROD, right? Now, with that, what I'd like to do is see if the board has any comments, but I would like us to stay long enough to have public comments. We do have 3 speakers, and if they're still here, I would like to give them a chance. So does the board member have a question or comment before we take public comments? Mr. Camus.
Yes, so I thank you for coming up with that solution, because there's just so much information being drawn back and forth here, and a lot of the assumptions I thought were troubling to me. One particular assumption that the ADA population is going to grow from 12% to 24%, I find troubling. I mean, maybe the number of people that have ADA needs will increase by 100%, but it doesn't mean that we're going to have a 24% of our population is going to need ADA. I want to know, I'm not asking for an answer today, but some of the assumptions I'm not necessarily convinced are going to happen. Who knows? Maybe genetic engineering is going to rule the day soon, and none of us will be handicapped in any way. But so I don't know about some of the assumptions. I don't know about the new rules and who's making them, because you all are talking past each other about whose standards are we following. Are we following California standards, European standards? I want to know what the fire code actually is, and I want to know. So if you're saying we could solve the fire code by doing this, and if you guys are saying, no, you can't, you need to let us know why we can't. And so that's the kind of information I'm looking for, not just, we're going to stick to our, we're trying to solve these issues, and we're not, I don't want to be talking past each other. I want us to go forward. We need to come up with a solution. We've taxed the population 4 times to get BART to San Jose, and we got to make sure we deliver. And because I think the population is going to get tired of being taxed and no results, quite frankly. So I'm hoping that that's what can be done. Again, I'm not looking for an answer today, and I want to thank you for doing this.
Anybody else? Go ahead.
Just quickly again, I'm not looking for an answer today, but to me, listening to the safety issue, I didn't understand what a safe point was. It's very clear what it is when you make it to the surface and you can run away. What is a safe point? What is it safe from? Does it mean closing doors from a sarin gas attack or a fire, and how do we make sure they can get closed? So a lot of definition about what is a safe point so we feel comfortable about it is a safe point.
Any other board comments? Okay, otherwise, I'm going to go ahead and have the public come up. If you could just line up at the microphone, any particular order. Sharon Friedland, Cheryl Jensen, Roland LeBron, and Abu Bakr. I am sorry. Abu Bakr Diaji. Thank you. I'm so sorry about that. Go ahead.
Hi, my name is Sharon Fredland, and I do serve on the Citizens Advisory Committee and also on the Measure A Citizens Watchdog Committee for VTA. But I'm here today in my capacity as the Executive Director for the Building Owners and Managers Association here in Silicon Valley. My association represents commercial real estate owners and managers and all the professionals that work in and on commercial real estate here in Silicon Valley. We are always excited to hear that VTA and BART are looking for better ways to get people working and to where they need to work in our valley. So we do applaud all of the consideration, all of the time that you're putting into how you're going to get BART into San Jose. That being said, my members line the streets. Their buildings surround the whole construction area where this is going to take place. So the impact of the construction is not something that, when you talk mitigation, they talk no access for my tenants, no access to parking, and transportation disruption for not just months, but years. So we do ask you to give serious consideration to the differences in the construction impact between the single bore and the double bore. The single bore on the surface of that does give us, quite frankly, on the surface, gives us better access and is less disruptive to our businesses. So we do ask for that consideration from the board. And again, we thank you for all the time and effort you're putting into this. I think all the safety considerations, the 100-year considerations, we care about that too. While those particular buildings may not be there, I can guarantee you we will have buildings there. And we will have people who need to be into those buildings. So thank you again.
Thank you.
Ariel Jensen. I'm alarmed at the impact that this will have on our aquifer. And it seems to me like the single bore would have a much greater impact. And so please think of that as you're choosing one of these alternatives. Our aquifer is probably the most valuable possession we have in this valley.
Hi, I'm with Working.
Can I pull the microphone up a little bit? Yeah.
Hi, my name is Abu Bakr NDI. I'm with Working Partnerships. I'm here to speak on the Garradon's station location decision. So from what I understand, VTA staff recommendations is the northern location. And from what I understand, the cost will be higher, about $50 million higher. And the rationale around it seems to be centered around the impact on the development around it, either the joint development or the downtown station development. And so I'm just here to note that we want to make sure that these decisions are made to benefit residents of San Jose. The public will be paying extra costs for either developments, like the development station, which is owned by Google's development partner, Trammell Crow. What kind of benefit will the public be getting, and in what form?
Thank you.
Thank you. So first of all, a massive thank you for the BART team for finally bringing sanity to the conversation. Thank you. Now, for the record, the Channel Tunnel cross passages have been around for over 30 years and they don't leak. We've had 5 major tunnel fires which led to the evacuation of thousands of passengers. We haven't had a single fatality. With regards to Barcelona 99 line, you just have to go to Wikipedia and read what it says. Originally expected to be ready by 2008, ongoing problems with its construction delays its completion until 2016. They were 8 years late. There's a follow-on article that says the 2 tracks run above the other, narrow tunnel for its first 4 kilometers, conventional double-track tunnel for the remaining 16 kilometers. If you read between the lines, Barcelona abandoned constructing stack stations within the tunnels after 2.5 miles, and they ended up 8 years behind schedule because they had to construct the rest of the stations with conventional platforms outside the tunnel. So the bad news is that neither of the solutions that we're presenting to you today are viable. The good news is that the British developed a new station tunneling methodology that makes it possible to construct 2 crossovers and 5 underground stations under central London, each with a west and an east portal, without any need for cut and cover or utility relocation. In closing, I would suggest looking at the station design on page 220 of the March 2015 SEIR scoping comments, is Appendix B, and follow that up with an on-site visit of the Bond Street Station, London, to learn how it was built without inconveniencing the 500,000 shoppers who visit Oxford Street every day. Thank you.
Thank you. Okay. So that moves us to other items. Oh, wait a minute. Oh, I'm sorry.
I just wanted to try and give the public to be able to get a chance.
Please.
I wanted to kind of just step back from this a little bit and try and understand where I'm at, because my understanding is this VTA board is a budget and policy making. That's what we go ahead and do. And to your point of what you're asking to be done, I'm hearing a lot of educated opinions about what things are, and I actually very much respect the experience of what is there. But if you come back with some kind of quantifiable piece, I'd like to really understand from a requirements perspective. I'm not interested in what people want something to do. We need to start at what the requirement is, and is the requirement met or is it not met? And one of the examples we keep talking, I hear about platform width, and here, what is the platform width requirement 50 or 75 years from now going to be different? Then that should be a requirement today that we need to build it that way. Not that we have a requirement today, but we might have to do something in the future. If it's not a requirement we're building to today, it's hard to do that. And to do that, as I was sitting here, I would be interested in us coming up with some decision-making criteria, because there's a lot of parameters that are discussed here that I'm not sure every one of those parameters that we kind of get off into that hole is actually a parameter that is what we need to use for making our decision. So I'm just kind of looking at it 4 macro level things. There's feasibility of it being able to be done, and it's feasibility, usability. It's the ongoing enterprise viability of something. If we build something, are the people going to be able to continue to use it 30, 40, 50 years from now? The cost, what is both the construction and ongoing, and then safety, I think, is an important consideration right there. But it would be helpful if maybe when you come back, if somebody tries to define what are the parameters that define how we need to make the decision, might be very different than all this other stuff that, depending on if you're trying to argue left or you're trying to argue right, you might want to pull us down into that. I think we need to make sure we stay at the macro level of this and not get too far down in the details. We need to understand the requirement piece versus just people's opinions. So that's, to me, what would be helpful. And I just also wanted to add on this piece of the idea of we need to have more meetings and a date. That's great. But I wanted to be very careful that the decision time doesn't move very far off of the October 5th, because I think that creates lots of other problems and challenges for us. So however we need to go ahead and do and get all this stuff together and somebody boil this up to a decisionable thing, not all the details of what's below that. So those are just my thoughts.
Anybody else want to chime in? If not, any announcements? I've got a few. Just a reminder that we have a joint VTA and BART board meeting that's being held next week on Thursday, September 28th. The meeting starts at 11 o'clock at the City of Fremont Maintenance Center, and it's expected to last 2 to 2.5 hours. We'll see how well we do on that one. There is also an optional tour of the Warm Springs South Fremont Station before the joint meeting, and that will be held at 9:30. I would encourage all my colleagues to attend because it is a great opportunity to meet our counterparts on the BART board and discuss some long-term partnerships. Staff is providing shuttle services for us in terms of doing the meetings. And then, let's see, and for those who are driving to the station for the tour, BART will provide shuttles from Warm Springs South Fremont Station to the meeting location. Lastly, our next board meeting is scheduled for October 5th. And again, we are now going to accommodate the wrap-up of this discussion that we've had today. Okay, so if there isn't anything else, staff, do you have anything to add? Meeting is now adjourned.